Now in this session we are going to understand what is meant by linked list. So linked list basically means, so we have already know what is meant by array. So array we have already seen, we have to initialize the size first itself. If you know don't initialize the size, it will be going to give an error. Or you have another option called array list, that is known as dynamic array. We have this concept in C++ language also. So this dynamic array will be used in the, if you according to your requirement. So other than that, we have another concept called linked list. So it is a quite opposite of the array and dynamic array. So what this linked list will do, that we are going to uncover all the stuff in this video. So basically we can read this definition over here: a dynamic node based data structure where elements are linked by reference, means pointers, not continuous memory location. So we already know array means the continuous memory allocation will be allocated for all the data that you are storing, and you can only store one type of data. In the linked list you can store one type of data, that's your wish, according to your wish. But the main important thing here is it's not continuous, guys. You can see here, so not continuous memory. So as this is not continuous memory allocation, you can have the memory random access. So with this, what you can have the addition. If you want to add the data in between, if you want to delete the data in between, so this is somewhat faster as compared to the array. But the searching operation, if the searching operation is very slow in the linked list, because so in the linked list we are going to search node by node, so that will take time. But in the array, that is array based indexing. So if you know the index, that's it. We can say that array the element is particular element is present in that or not. So if you see that only here we have two types of linked list, that is singly linked list. Here LL means the linked list. So we also have another kind of linked list called doubly linked list. So in the singly linked list we have the two nodes, that is data part and next part, and this next part is connected to the next part of the node. So this same node is replicated here, the same node is replicated here for the different data. Here we have another data, we have other data, another data. So at the last node, the next pointer will be pointing to the null. So here the next pointer is pointing to the next node, like that it will be all the linked list will be over there. So why we call this as linked list? Because the this data is linked to the next data, this data is linked to the next data. So this is like a chain or a list. So that is why we call as this is as linked list. So this is the first node. How can we know as this is the first node only? We should have another pointer as this is same. So that is known as head. So with the head pointer as the same as this one, but both of them will be the second next pointer will be null, and the head pointer will be pointing, the data pointer will be head, that will be pointing to the first node of the singly linked list. Okay. So the similar concept we have in the doubly linked list as well. So in the doubly linked list, so we can also traverse backward. So in the single linked list we can only traverse forward way. If you want to traverse at a time forward, backward in a single linked list, so we can achieve that with the help of the doubly linked list. Okay. So there are two types of implementations. They inbuilt we can implement in the Java. We have the linked list class. So with that we can implement, or we can use, or we can build inbuilt linked list by ourselves. So now we will understand what is meant by array list in Java. So array list we have already discussed. It is just extension of the array. So this array list is also known as the dynamic array in C++ language. So in Java we call it as array list. So if you read the sentence over here, it says array list uses an array which allows for fast random access but slow insertion and deletion. Because if you want to delete, so if you want to insert or delete in between, so you need to shift all the data, all the indexes you need to shift, and in between for inserting one data in between. So that's the main drawback of using arrays and dynamic arrays. It's just the array. Suppose it's just the array, then what is the use of this dynamic array or the array list? So basically, if you observe clearly, I have an array called AL, which is of size 10 in this case, from 0 to 9. So suppose after filling all this stuff, you want to insert the 11th element. How can you insert that 11th element? So for inserting that 11th element, you need to have the extra space, but we do not have. But don't worry, in the dynamic array, what we are going to say is, so with the help of these old values, we are going to copy. With the help of these old values, we are going to copy all these 10 values to the another new array. But here we have extra space now. So this is known as the dynamic array. So you are not going to manually create this one. The Java itself will be going to create this dynamic array. The bigger array copying all the stuff here for you. You just need to create this one. You just need to create AL. So inside that automatically it will be going to create this one whenever you trying to insert the 11th element. So this is known as dynamic array. Here also you can see the same stuff, 10 elements, but after filling the stuff, after filling half of that, so not that 10 elements, after filling half of the elements only, you can see over here, after adding the 7th element, a new array list is created with capacity 20. I hope this makes now some sense. So as the full capacity is there, but if you have the capacity half more then it will be going to create an extra size. So extra size of the size double than this. So this is known as array list. So but this is also somewhat like array. The index is faster, you can see. So allows faster in random access but slower insertion and deletion. If you want to delete this fourth option, you need to shift all this stuff towards front for the single operation. So for that purpose only we are going to use the linked list. So linked list is faster if you want to delete and if you want to insert data in between. So after that we need to understand where this linked list is present inside the collection. So we already know collection interface is an interface. Here you can see. So basically we cannot able to declare the function inside this interface, or we cannot able to create an object for this interface in Java. So basically this collection is implemented with the help of this list. So as this list is failed to implement this collection interface, so it also become an interface. So this list is now implemented with the help of this array list, okay, or this list is implemented with the help of this linked list, okay, or we can use this queue interface. That data structure we will be going to explore in this session, in the sessions in this DSA only. This key also important, okay. We are understanding now this linked list, or you can see simply with the help of this diagram as well. In this diagram what they are trying to say is basically this diagram and this diagram is same, but you can see the green color represents the interface and the blue color represents class. Here you can see the linked list, array list, vector, stack, these and all stuff is the basic data structures in the DSA. So this and all will come under the interface list. So this interface will be implemented with the interface collection. So I hope this makes some sense now. So we have also the interface queue. This interface queue will be implemented by the queue collection. So this the queue interface will be implemented by the collection queue, okay, collections, okay. In this we are going to have priority queue, booking, blocking queue, and all this stuff, okay. I hope this makes some sense now. So we are going to see the hash set is a class which is implemented by the interface set, and this interface set is implemented by the collections interface. So overall we can say this collection is an interface which implements all these three stuffs, or in this only the linked list is a subset. So we understood what is meant by linked list. Now we are going to understand how we can add a node. So basically this is the node structure. We have data part and the next part. So this is known as node, okay. So what we have to do is we need to add at the end. So you can see we have a head pointer that is pointing to the first element, to the first address. Now what we need to do is we need to add this new node at the end. For that we need to have a new pointer that is same as the head, that is which is the same address 100, which is pointing to the first element of this linked list. So with this current pointer, what we can achieve is I will be going to explain now. So first of all, point this current pointer to the first node, and you need to make this new node and fill the data and the next with the null, okay. Ready, keep it ready. So after doing that, so don't move this head. If you move this head, you are going to lose this first node. So if you want to traverse the whole array, you need to definitely have a current pointer. So after having this current pointer at the end of this, so next you need to append this new node here. Then how can you move from first node to the last node with the help of this current pointer? Basically you can use while loop. So you can see how I used while loop here. So inside the while loop I am checking while current dot next not equal to null, means that, so as first current is here, you can see current is in the head. So current dot next means the current next is here. So current dot next means it is pointing here. You can see 105. So this is not equal to null. So you can able to move from here to here, that you can see here. So it is moving from here to here. How it is moving? It is written over here. So current is equals to current next. So basically you are moving from current is equals to first current next. What is current next? 105. So first current will come here. So after that it will again check. It is again not equal to null, that current dot next. No, it's not. So it again comes here. So then again we are incrementing that current is equals to current next. So after this current pointer pointing to the last element in the linked list, the next step we are going to do is with the help of this statement we are going to add the new node here. So what is that statement? The current node is pointing to the last one, and we can simply say current dot next is equals to new node. So simply this current dot next is equals to new node, that's it. So there is no need of making any other connections. That whole connections has been made. So this is how you can append any new node at the last of this thing. So adding a node at first. So before seeing this, let us see practice. So I currently in my VS Code, what I am going to do is, so first I am going to show you how you can use the inbuilt linked list. So this is the inbuilt linked list, which is coming from the java.util.linked list. Okay. So basically if you hover that, it will be going to say as linked list is the class. Okay. So we are going to have a linked list. So in this linked list, we are going to mention the type of the thing that we are going to store in the linked list. So I am storing the integers. I am wrapping with that is wrapper class. This is known as wrapper class. This is the class integer. Okay, we are going to store the integer types in this linked list. Or if you don't mention also, no problem. That will also I will show. So in nums is equal to, you can create a new integers. Okay, new linked list you are going to create. So I will say new linked list. So in this linked list, what I will be going to say is like this. So this is the stuff how you declare an linked list. If you remove this integer, what happens? Let's see. So if you remove this integer, there is no issue. Here also, if you remove these angular brackets, there is no issue at all. But for our sake, for understanding, for clarity purpose, what we are going to store in this linked list, that we are going to have a notation. So that's why we need to mention here the integer. Inside this also we can mention integer, but there is no need. Why? Because we are already mentioning integer here. So that's why it is showing warning over here. If you hover that, redundant type of argument in new expression. So as this is the new type of linked list that we are using, there is no need to mention this integer over here. I hope this makes some sense now. If you remove this, what happens? There is nothing happens. So basically this is meant by that you are creating a new object that is called nums. It is coming from the class called linked list. Okay. So you are creating a new object with the help of this new linked list. I hope you know how to make an object. Okay. So after having this, you can just simply say nums.add. That's it. So you can add how many elements that you want. You can pass integers. Okay, there is no issue in that. And if you pass another integer, nums.add. So basically you can see I am passing both 5 and 9 over here. So there is no issue in this. So after that, what I will be going to say is I will simply print these two, whether those are printing in the terminal or not. What I will say is nums, we will just try to print the nums. So let's see what happens. So if I compile and run, you can see it is showing warning. So the warning it shows, but ultimately it printed all the stuff for me in the terminal. Why it is showing warning? Because it is saying, so linked list okay, it is let me mention the angular brackets here and let us rerun. See, after if you mention the angular brackets again, it is not going to throw this warning also. Okay, if you don't mention this also, there is no problem, but it throws error. So I want to give you the full explanation. That's why without that I gave first. So after that I kept the angular brackets and show you. Inside this we can also pass the integer, but I have already shown that, but it is not required here. Okay, this integer is not required because it's showing warning over here. I hope this makes now some sense. It is successfully printing now, you can see over here. So after that, in this linked list class, we have so many methods. If you hover over that, so it will be going to show you all the stuff. So basically if you go inside this linked list class, you can see explore all this public class linked list. So inside you can see all the stuff. You have a method called linked list, and if you come down you have a method, okay, linked list. Okay, so linked list first you have means you can append the values at the first. Linked list last, you can append the values at the last. So linked list before, so whatever the node you want, that you can append something in the linked list. So that also we will be going to see manually in this session only, how you can append a value in between two nodes. Okay, and how you can unlink two nodes. So unlink last, how can you unlink the last node? So there are so many methods. So you can get last element, so you can just see what is the last element. You can remove the first element, you can remove the last element, you can add at the first. Oh, there are so many methods. So in this video I will just quickly show some of the methods, okay, so that you can understand. So some methods say is I will nums dot, so you can see it is showing all the methods. So I will going to say get first. So okay, in this get first I will put semicolon. So that's it. If you store this, I will say int result, or I will show first, and if I print that, let's see what happens. If I try to print the first, let's see what happens. If I compile and run here, basically it is showing the correct thing, because you have added the first one, that is 5 in the linked list, and you have added the 9 in the next one. So if you see the presentation, basically here that's the stuff we have seen up to now. So how to add an element at the end. So this is the stuff. So if you see here clearly, we are having this node first. So we are pointing head here. So we this is happening beside behind the scene, because those and all things are provided by the Java itself. So after this one, it is we are adding the 9. So the 9 or 6, anything, that is your wish, any number. So after that, it is appending this thing. If you want to append anything, and after that, after this number, it will be going to append here. So like that, we have already seen in the linked list class, there are so many methods that we can. Now in that methods, we have explored one method that is known as get first. Like that, we can, if you say the get last, let's see what happens. If I say get last, so let's see what happens. If I again compile and run, it has to given me 9. So you can see it is giving me 9 output, and finally it is printing the final array due to this nums. Okay. So I hope you understood what is meant by get first, what is meant by get last. You can see here. So with the help of this link, this nums basically is an object. See, this nums basically is an object. So you can object dots, you can call the method. So method name is the get last. You can also say some of the stuff like, I will remove this one. Okay. I will also inside this printing stuff, what I will be going to say is, so I will just say nums dot get. You can also get the index. Suppose if you say get at index 2, so you can simply mention the object dot just get. You need not to mention any get first, get last. You just mention get, and inside the braces you can mention the index. But unfortunately, we have only 2 elements. I will also add the third element, which is an index 2. Suppose if I add 20 here. So if I compile and it has to give me 20. Why? Because 0, 1, 2. Or basically, if you using linked list, this does not make any sense. Because array has index, dynamic array has index, but why linked list will have index? So we cannot say this is the first index, we cannot say this is the second index, we cannot say in this manner. Linked list are not zero based indexing, or linked list as is not any based indexing. Linked list is not indexed based search. So basically it is a search node by node. If you want to search anything, it will go node by node. Let me see what it will be going to get me, what is at the index 2. If I compile and run here, see, it is giving me 20. At this case, it is giving correct, that is at 20. So it is applying some algorithm and giving me at what is index at 2. But don't use this kind of indexing. If you want to check is that 20 is there or not, you can use some of the higher algorithms that may come into picture. Okay. Or if you want to have the highest speed of search, you can use dynamic array, that is array list. That is in Java we call it as array list. You can use that. That will be majorly used in the project and itself. So but in this video, the aim is to show not with the help of this package. I will be going to remove this package for you, and on the top of this class demo, what I will be going to do is I will be hover over that. If you see quick fix, if you click quick fix, it will be going to show some of the things that you can do over this error or warning. That is add import. I don't want that. So create a linked list in demo. I don't want that. So it is saying create a class. Yeah, I want this class. So it will be going to create a class in separate another file, or if you want, you can also create in demo file. That's according to your wish. Okay. So there is no issue. But here it is showing nums.add. So we do not have currently any add function. So I will just remove this for your sake. So if you hover and click, it will be going to, if you want in the demo, you can do that, or if you want other file, you can also do that. So I will be going to remove this stuff here, or so basically I will come to this class linked list. So inside this linked list, you are going to have some stuff that this is the structure that you need to make dynamically. Okay, if you will be going to get some element. So with the help of the object, so in the demo, if I say suppose I am creating a object of nums, if I say something like nums dot add, means what it will be going to, I will pass an integer. Okay. So if I pass, this is the method. With the help of this object nums, you are going to call this add method. So inside this, you are accepting an integer. Okay, this I hope you understood. For now sake, I will be going to comment this. So inside this linked list, you are going to make the structure. Before that, each and every part, this is known as node. We have a data part and we have a next part. You can see over here. We have a data part, we have a next part. The same stuff that I want to do in the top of that. So I will be going to say class, and I will be going to create a new class called node. Okay. This will be going to return a node to this linked list. So inside this linked list, we are going to have main logic so that we can connect all the nodes. But if we need to create every node, so I will say into data. Okay, if I will say into data here. After having the data, you can simply say pointer, that is the node pointer, that we can name it as the next. So there is no issue. This is same as other languages like C, C++. So basically this is a capsule. This will store data. This is single list that we are making now currently. So inside this node, we are making a pointer, next pointer, that is we have named. So I will be going to have a constructor. Constructor name should be name as the class name should be same. I hope you know the stuff. So inside this I will be going to say this dot data is equals to data. Basically this constructor here we can have the int data. This constructor is parameterized constructor. We will accept the data, keep this data inside this data and put the semicolon. Okay, and we are going to keep that next pointer is equals to null. This is the basic stuff. Whenever you create an object, this is the basic stuff. So fill the node by using these stuff. So fill that when you're passing here, if you come to demo, when you're passing new dot add, so add will create a new that node, but that has to fill with this coming integer. Okay, if I come here, the data will come here. Okay, the data will come here. Whenever you are creating a new object, the data will come here and it will be going to store in this data, and the next pointer is initialized with null. If I come to this linked list main class, so inside this what I will be going to do is, so I will be going to say public because that is in the other file. So you are going to say public. So inside this I will be going to say public void. So I will be going to create a function. So function add. Okay, it will be going to accept an integer int data. Is there any issue? There is no issue, I think, because we are passing I commented it. I will remove comments from here. So basically you are calling add function and passing an integer. In the linked list also you are creating a function and accepting an integer called data. So after creating the function, what you can do, you can create the new node, and you can say it as new node. Okay, the name is new node, and you can say an object. Okay, basically you are creating an object of this class. Basic, that is only. So the reference is of node, then the variable name is a new node, and new key with the help of new keyword say node, and in the constructor you can pass the data, because we already know whenever you create an object like this format, and this will be going to call this constructor. So inside this constructor we are accepting the data. Here we are passing data. So this makes some sense now. So it will be going to fill this data with this data. So the incoming data is filled in this data, this variable data, and the pointer will be filled with null. So after that what you can do is, with this new node you can able to do the stuff. You can able to start. So first of all, as you can see clearly, we have a head. Head is pointing to the first node. That purpose, what I will do here is, I will be going to create a head that will be initialized with the data null. So there is no issue in this. Okay, we are having a head that is initialized with null. So inside this if statement, what I will be going to do is, I will be going to check whether this head is equal to null. If that's the case, then I will be going to have the stuff that I will be going to reassign this head to new node. Okay, I will be going to assign this head to new node. So because as we are having this object, we are creating this new object with the help of this node class. Here you can see we have created on the top. So with the help of this node class, we are creating an object new node. So we are assigning the new node to head. You can see in this. So we are assigning this new means we are pointing basically this head to here. Now rather than this head is null, it is pointing to the first node, which is 100. So these two connected. Now to add a new node that so if you say that if head is null, okay, here it is saying head is null, we are going to have a new node. If head is not equal to null, if head is not equal to that some data, so what we can say is head dot next is equals to this one. That's it. Head dot next is equals to some new node. So in that else statement we are going to say that only, but we are going to say in the while loop. Why we are going to say in the while loop? Because so for your simplicity, I have placed the demo.java here and the linked list.java here for more clarity. So in this linked list, we have one class that is node class. So the main class, that is the linked list class. It has also a type. We are introduced the type safety also. So we are having the null here. But inside this inside this while loop, what we are going to check? So we have already discussed about this. If you want to have something a new node inside the end, or if you want to append a new node at the end of this linked list, what you want to do is you want to create a new current pointer which is at the same thing. So the same thing that I want to create a new node which have, so I will say here, so that node name is current and which will be same as head. So there is a issue. I think there is no issue in this. So I created new node. This is basically you are creating an object. So here I am creating an head, that I'm creating an object of node which is same as head. So inside this while loop, what I am going to check is if current dot next. So inside this while loop, I will be going to have the, basically you are traversing all the array, and you are traversing all the linked list, and you are going to up to the end. If current dot next is equals to null, you are stopping and you are coming out of the loop. So after coming out of the loop, what you are going to say is just simply mention current dot next. You are in with this line only you are going to append with the new node. Okay, whatever you are creating the new node here with the help of this node class, just mention the new node. That's it. Our whole job has been done, mentioned like this. So whatever you creating here, just assigning to the current nest. That means, so whatever you are with the help of this current, you are traversing up to the last. So after traversing, you are pointing this one here with the help of the syntax, and you are checking current nest not equal to null. Yeah, here it is null, so we will be going to coming out of this loop. So after that, we are able to join the new node is equals to this statement, the current dot next pointing to the new node. This is the thing that how you can add the node at the missed here. We need to print all this stuff, all this on how many addings. We have 3 elements in the linked list. We have added in this successfully, but we are not printing in the terminal. So for printing, I will be going to say here. So basically, it will be going to print all the stuff in the terminal, and I will be going to call this function. So this method does not exist now. If you click on quick fix, it will be going to say you create a method print value in linked list. Yeah, I am very happy with that. So if you come to again to the linked list.java, it will be going to create a method. So in this print values, what we are going to see is we are going to print all the values in the stuff. So for printing all the stuff, you need the current pointer, because you are going to traverse whole the list. So without traversing, you can't do anything. So you can initialize with the head. Why we can initialize with the head? Because if you see clearly, we are having the node, we are creating the node outside this add method only. So we can use as this is the global variable head, we can use inside this print values also. Again, that is initialized with current. So after this statement, what you can do is again for the traversal, you can use the simple thing, that is while loop. So you can also check current here not equals to null. Okay, here in this case we do not head is what, after you are adding 3 values, you can see we are adding 3 values here, adding 3 values more. After adding 3 values, the head is now is at 5, so head is not null here. So after the add function only, you are implementing this print value function. Okay, so after completing this check, and what you want to do is you can print all the stuff in the terminal. So you can simply say s out. So inside this s out, what you can say is current dot data. After that, I will be going to say current increment. So current is equals to current dot next. Basically, with this statement, you are printing all the stuff in the terminal. With this statement, you are going this is not capital, this is small. Okay, so with this statement, you are printing all the stuff in the terminal. With this statement, you are incrementing the current by one by one each element you are going to print in the terminal. So if I come here, if I compile and run, so you can see we have 3 elements. The 3 elements has been printed successfully in the terminal. So this is the way how you can implement manually. You are creating a node, you are creating a separate function for the linked list, and you are going to print the stuff in the terminal. So if you that is 5, 10, 65. So if you want to add something in the terminal, that is example, if I add 100, and if I again compile and run, you can see those and all values are printed, because we are using the while loop here, and we are while adding, we are also using the while loop. So that's why it is able to add all the stuff. How many elements are we are adding, the same and all added with the help of this single if else statement. So that 100, 99, 79 is also printed successfully. So what if you want to remove some elements? Suppose if assume that if you want to remove 5, how can you achieve that? So, or if you want to add 10, not 10, if you want to add 6 in the beginning. So before 5 you need to add 6. So if you simply come here, if you say this statement, this will be going to add the 6 after the 79. It will be not going to add before the 5. If you compile and run, you can also observe that. So we are getting the order as we have added in that. But the 6 is added at the last. But we don't want this 6 to be added at the bottom. We want this 6 to be coming at the top before 5. How can we achieve that? That is known as adding an element at the top. So you can simply cut it here and you can paste it here. But that's not the case. With the help of the code, how can we achieve that? Before seeing that, we need to understand. With the help of this presentation, we have understood how to add at the end. So by this end of the statement, you can able to simply achieve this simple linked list. So where you can have a single straightforward linked list where all the elements has been added. So after that, what if you want adding a node at the first? If you want to add a new node, if you want to add at the first. So in this case, what you need to do is just keep this linked list aside. So with the help of this head and new node only, we are going to have some magic. Here we don't need the extra current pointer as well. So current, you can see with the help of the single line new node dot next. So this is new node dot next. So this will be having the head. So this head will be pointing here, this new node, and inside this new node we are having 100 means it will be pointing here. If you come back, you can see new node dot next. So this is new node dot next is equals to head, means head is pointing to this one. So this node will be pointing to here. So I hope you understood this connection. In this, with the help of these two lines only, you can able to add a node at the. So if you see code wise also, so after this printing values, you can, so before printing only, you can come like this here and you can create a new function. So I will say here only. So I will say nums dot add first, and I will go into pass 22. So there is no 22 here. I hope there is no 22. So I hope this works, but it is showing error because we do not have a method called add first. So simply hover over that, it will be going to ask quick fix. So click on create method add first in the linked list. So it will be going to create a method called add first in your linked list file. So simply remove this thing here. So inside this add first method, what we are going to do is we are going to have some stuff. So you are going to have another node. So say new node. I hope this makes some sense now. You are accepting an integer I and you are passing an integer I. Basically this will trigger this constructor data and it will be going to initialize the data with that data and the next pointer with the null. So if you come here and if you say that two lines, what are the two lines that we have seen in the PDF? That is say new, that's it. Our job has been. If you see here, if you come back, so you can see new node dot next is equals to head. So with the help of this line, you can see you can connect these two. So new node dot next will be pointing here. So after that, you need to make this connection here with the help of this line. You need to make head to here. So you can mention head is equals to new node. With the help of these two lines, we can able to successfully achieve, but we need to have this function before the printing only. So after printing also there is no problem, but it will print and it will not show this add function. So what I will going to do is, so first of all it will be going to have, so I will comment out here for you. Okay, I will be going to compile and run for you. So basically you can see there is no error, there is no issue. It will be going to show you the first element as 5 and the last element as 6. Now I will be going to remove these comments here and I will be going to clear the terminal for you and I will be going to compile and run. Then you can see it is adding 22 at the first because we are passing 22 here. We are passing 22 here. That we have already discussed how to add with the inbuilt Java library which is coming from java.utils. So that with that collections linked list, this linked list also we can import from that object, that linked list class, and we can able to do that. We can add at first, and with the help of this function, our inbuilt function also we can achieve by adding at the first. So it's the same way we can also add at the last. That is homework for you. Try it by yourself. So after this, what we want to achieve is we need to delete the target node having 5. So what if someone came and have saying that you have these elements, they want to delete this in between element. If you see here also, suppose we have only four elements, let's say. So 1, 2, 3, 4. But I will be going to comment out here. Okay, I will be just going to have 4 elements in the linked list, and this 5 is headed with this the head pointer. You can see head pointer is pointing now to the head pointer here we are creating, that will be pointing to this 5. Now basic thing is that you need to delete the value of 65. How can you delete the value of 65? And just you need to print 5, 10, 100 in the terminal. So this has to be deleted. I will write comment here for you, DLETED. So this has to be deleted and remaining things has to be printed in the terminal. Now let us understand with the PPT so that how you can simply have your custom function so that you can able to manage the stuff. So after coming here, I will be going to say nums dot delete. So inside this delete the 65. Okay, if you hover over that, you can see quick fix. So click on that. So it will be going to say create a new method, delete, it will accept integer. So inside this linked list, so click on that. So basically what it will be going to do is it will be going to create a method here for you. Wait, it is just loading here. Or if it is taking some time, means what you can do is come here, just you can mention void and you can say delete. Inside this delete you can accept an integer. You can say into data, with this data inside that, what see here error has been gone successfully. So inside this delete method, what the logic that we want to perform is, so again if you come to the slide here, the numbers are different but the logic is same, so just focus on the logic. So these numbers made by me only, but for the slide the numbers are different. For the presentation, for the actual code, the values are different, so there is no issue in that. So you want to delete this one. For that deletion, again you need to have the current pointer pointing to the first one. So you need to make this current pointer to before the deleted element. Here the deletion element is 5, so you need to make sure that current is coming up to this the but1 node. So yeah, with this image you can confirm that you want to delete 5 means you are going to point this current pointer before the deleting node, that is before deleting node of 5 is 8. So you are going to point this current pointer to the 8 with the help of, you can achieve that this kind of situation with the help of this kind of small code snippet. So how can you go from this pointer to the value before node? So simply say current dot next not equal to null. Okay, because if this current dot, if so suppose first of all you are here, so you are, when you are here, the current is here, current dot next points here. So when this is null, you are going to delete the last element, so that's no problem. So and current dot next dot data is not equal to 5 in this case because we are deleting the 5. So what is meant by this? So when you should not go directly onto the 5, you should be on the before but one element. So make sure that you are on the before element, not on the direct element. So that's the stuff I am highlighted with the gold color. So until unless then you are going to traverse whole the linked list with the help of the current is equals to current next statement. So after traversing whole of that with the help of this if condition, you can able to simply cancel this link and you can able to connect directly over here. So you are checking that current dot next is not equal to null, means you are here, current dot next is not equal to null, means you are checking that is this not equal to null. Yeah, if that's the case, what you are going to do is current dot next means here 110 has been upload, means from 110 we are taking from here, we are keeping here. So current dot next. So this is current next. So this is current we are pointing, this is current next, means this is the current next value, and this is the current next value that we are able to assign in the current next value. So I hope this makes some sense. Now we are placing 110 directly here. So this will be now moved to garbage. This garbage collection can be handled in Java by itself by JVM. So now if you see, now the final after deletion, this is the print, the final clean after clean having this. After you deleting the node 5, it is the clean array of the linked list. Now we are going to understand the same stuff with the help of the code also. So if we again come to the code part, we have already seen how to create a function for the deletion. So inside this deletion, so I again as we already know, we need to create a function called current, which will be initialized with the head. So after creating this node, what you are going to do, again you already know, you are going to traverse with the current value current dot next. So this current dot next should not be equals to null. And we have another condition also to be checked. We already understood with the help of slides also. So current dot next dot data should not be equal to data that we are accepting here. Why? So you can see we are having data only, no problem here, because what is meant by this statement is we all understood in the slides itself. So we should not go with the current pointer, we should not go directly on the node that we are deleting. Here we are deleting the 65, so we should not go directly on the 65. We should be before the but one element, or but one node. That what I am going to trying to say is. So inside there you are going to traverse like this. So you are going to say current is equals to current next. So current dot next. With this statement you are going to traverse all the stuff. So you are an ENT, so don't make spelling mistakes. Okay. After traversing, after you are getting to the last but the deleting but one element, so you just need to check with the help of this if statement the current, check the if current dot next is not equal to null. If that's the case, current dot next is not equal to null. If that's the case, then inside that you are going to say dot next. I hope this makes some sense. Now you have seen already this stuff in the terminal as means the PPT as well. Now you are seeing here also. So you can see we are passing 65. Now it will be going, if I compile and run, it will be going to show only 5, 10, 10, and it will be going to show 100. Now let me compile and run. You can see clearly it is not showing 65 in the terminal. We are only deleting 5, 10, and 100. So you want to delete this thing. So what you can do is you can simply come here and you can say 10. After mentioning 10, what you can do, you can just simply compile and run. Sorry, 5 and 100 it is printing in the terminal. So what is meant by that is it is deleting successfully. So we have made the deletion part also successful. So this is how you delete. This is how you make the node function which will creating node. So this is the main class that we are doing all the stuff here. So linked list class, in the linked list class we are creating a normal head pointer. Inside this we are adding at the end. So adding at the first, adding and deleting, and we are printing all the stuff in the terminal. So if you see in the demo class what we have here, we are passing all the values, we are deleting the values. If you want, you can add or come down and you can say nums.add and add first. You can say inside that you can pass 35. Okay, that's the simple stuff. And if you again compile and run, you can see 35 will be added at the first, because you are saying add first. So add first, delete, print, last, add last, these and all, add last here, add one. Again, if I come to the slides, so again one more thing that I want to discuss is if you want to add something in between anything. So the last thing for the linked list is, so what if you want to add back this 5? So we have deleted this 5 in between here. So you want to add between again 8 and 9. So if you see here, we have again current pointer here, last but one here. So as we have seen the logic here, if you see, so with the help of this while loop, what you can going to do, again with the help of this while loop only, you can come up to here. Why up to here? Because you need to add between 8 and 9. So whatever the node you are adding, so before that only you are going to place your current pointer there with the help of this kind of syntax. After coming there, what you can do is you can simply add, okay. So after coming here, you can create a new node. So initialized with the data that you are trying to here is 5. So the next pointer is pointing null. It has some address 105, okay, 105. So with the help of this simple if statement, you can able to check is current.next, means current.next is not equal to null. If that's the case, if this is not equal to null, what you can do is new node.next, means this new node.next, this take this 110 and place it here, means that is current.next. This current.next that is pointing to here, this 110 will be placed inside here. So this link has been successfully completed. Now what you want to do is just break this link and make this in this way. So in this way you need to have, see clearly in this way. So if you see in the next slide, so that's the same thing. So if you come back, the same thing that I am making here, in this fashion you are going in this fashion. With the help of the current.next is equals to new node, means this is current.next is equals to new node. That's it. Our whole job has been done. So this points here, this points here, this points here, completed. You can see this is the way that we are going to achieve the new node of with the value 5 that is successfully appended in between 8 and 9. So I am not going to show the code for this one. So simply up to here you already know. I am giving code snippets here also. You can simply try it by yourself. Assume that this is your homework and try it by yourself. So I hope you understood all the concepts about linked list in this session. So in this session we are going to understand what is meant by stack and its implementation with the help of array. So if you observe the definition of the stack, it is just a simple thing, that is LIFO. So last in first out, you can see with the help of this diagram as well, it is saying whatever the value comes last, it will go at the first. So I hope you see in the regular life, whenever you are putting a pile of books on one another, so that is known as stack. You are placing one object on one object, one object on one object, like that you are placing a pile of object. So if you want to remove the bottommost element, first of all you need to take the topmost elements, all you need to remove, and at last you can take whatever the required thing at the bottom you want. So that's the same principle in the stacks also we will be going to follow. This is one of the data structure. So this is the linear data structure that we can be used with the help of whether we can use arrays, or we can use the dynamic arrays, or we can use the linked list. That is according to our use case. So that's see, you can read it, that follows last in first out principle. You can see with this small animation also that says here push. So inside this stack we are pushing first element A. So after this we are pushing the second element B. If you want to retrieve the element A, you want to first pop the B, okay. And if you want to see what is the on the top of the element, that is known as peak. Peak means to see on the top of the element. So you also need another variable called top. You can see over here that this top will return the topmost element. Here the top value is 6. Basically this top is a pointer which points to the topmost element, so that we can track what is at the top and how we can remove or we can add on the top. And the last operation is we can remove the element, that is known as pop. So in this stack we are going to have mainly these main are the three operations, that is push, okay, push, pop, peak, okay, push, peak, pop, these three operations. And then if you see the hierarchy of the stack, where the stack in there, so inbuilt in Java. So we are going to see the inbuilt stack in Java, and we are going to also see our custom stack. Our custom stack means how we have created our custom linked list in the previous session. In a similar fashion, we are going to create the custom stack without using the Java's inbuilt. But we are going to understand the stack's hierarchy, so that is very better in the mind. So if you see clearly, stack extends, basically stack is a class which extends to vector. So vector is a class which implements the list. So basically here list is an interface which extends collection. So basically collection is the ultimate interface. You can see with the help of this diagram as well. Here the green boxes are known as the interfaces. The blue boxes are known as classes. Here you can see the stack is under at the bottommost one in the list. So here list is an interface which will not implement the functions which we can only declare there. So inside that the stack function is declared. So this is failed to implement in the collection. So collection is also an interface. So what operations that we can be performed on the stack? If you see, we have push, we have pop, we have peek, is empty, is full, size, clear. So these are the operations that we can able to perform on the stack. So I hope you know these three things that I have already explained before. That push means insert element, pop, remove, peek means to view on the top. So is empty, is full means we have to check the stack whether, let's see that also. So first of all, we need to check. So suppose this is an array. If this is an array, we can have to check definitely. Is this able to accept more elements or not? Because the array is of fixed size. Remember, array is of fixed size. We need to declare the size first itself. In the linked list, that's not a problem. Okay. If you see clearly is full, is empty, we need to check definitely, because if there is no element, but you are trying to pop that, you are trying to remove an element, is there is no element, but so then that situation we need to create this function that is known as is empty. So or is full. If that stack is full, you are going to get stack overflow error that we need to custom message that to the user. So we have size, so we can get the size, what is the number of elements that we have in the stack, and we can clear all the elements, remove all the elements. So but majorly we are going to use these three. So yeah, you can see we can implement the stacks with the help of the linked list on arrays. I already mentioned before. So in this session, we are going to understand with the arrays, because that's simple somewhat compared to the linked list. But once you understand this one, this is also somewhat, if you try it, that is also easy only if you know the linked list concept. And a simple concept in this that with the help the stack with the help of this linked list, I will be saying once again. So I hope the push, the pop, the array, we have seen the linked list, this one. Okay. So basically you can see head is pointing here. We need to perform push here only, pop here. So what is meant by that? So we know in the linked list the head will be pointing to the first element, and we need to perform the push from the last and pop from the last. But here last means near the head. Understood? So now this makes some sense. You might be confused now this time. While what is this kind of situation? Why you are doing push here and pop here? Because this is the head, this is the top. Here head is known as the top. So we are doing all operations from here. This is known as bottom. So you can see, you can get clear from this image. So you need to perform the push here, the pop here, and the head is here. Because this is the most recently used element, and here the oldest element. In the linked list I am saying. In the array it is normal stack implementation. So if you read this sentence also, so perform operations push pop from the head only. Why? To get order of one complexity. This is very important. For the getting order of complexity, we are going to perform near head if you use linked list. So if you can also see the array based stack and linked list based stack. You can see the pop operation will take order of one, peek will take order of one. So space will be based on the size that we are performing, and push is also order of one. Okay, you can see it is guaranteed. It is amortized based on where we are inserting, or where we are inserting. Now currently I am in my VS Code. So currently with the help of the inbuilt stack in Java, I will be going to show you first. So if you type the stack, you will see clearly the stack is coming from java.util. If you click that, so stack will be imported. Stack will be imported from java.util, and the stack is a class. If you hover over that, you can see the stuff here. Or if you want to know more about the stack, you can control click that. If you control click that, it will be basically redirecting to class, the stack class. Inside this stack class, we can see all the methods. We have push method, means a push method. We have peek method. If you come down, we have this is the method. Sorry. If you have, it will check is empty or not. Search. Okay. Yeah, basically these and all the stuff we have in the stack. Okay. Yeah, understood. Now what I will be going to do is, basically this stack is a class. For class, what we are going to do, for the stacks we are going to create an array. So I will name it I will name this object, okay, as nums. So I will say new, and I will say of type stack. So this is the simple syntax that I have made. You can also introduce the type safety. I am going to have only integer inside that, and you can also have the type safety here, and you can inside that with the wrapper class you are going to say only integers I am going to accept. But you need not to mention here, because you are already mentioning here that all the elements coming inside, that is integer only. But if you mention integer or not, that is your wish. There is no problem in that, because if you don't mention the basic type inside this stack would be, we are storing inside these nums are objects. Okay. So now I will say nums dot push. We already know what is meant by push, what is meant by pop. Okay, I'm just pushing the value of 5 inside this nums. Okay, so after that I will be going to say nums dot push. Again I will be going to push let's say 40 or 70, anything, and another number also. For example, I am just 90. Okay, so after all this stuff I will be going to print some stuff in the terminal so that you can see what is there actually in the stack. So you can simply print the nums, this nums object you are printing. In the object you have 3 values, 5, 70, 90. So if you compile and run, so basically it is showing all the stuff warning up to here, but finally you can see it is showing 5, 70 and 90 is our output. But what is the warning here? What is it is showing 3 warnings. The warning is you need to definitely introduce the type safety here. So what I will be going to say is I will be saying here inside integer. Okay, there is no warning. Now I will be definitely going to again recompile that. Now you can see the warnings has been reduced. So if I again mention the type safety here also, if I again compile and run, see there is no warnings, there is no error here, because you definitely want to mention the type safety. What is the type that I am always pushing? Integer. Make sure you always push the integer. So if you not push the integer, if you try to pass the array or string, so basically it is showing warning here only. For that purpose you are going to mention the type safety. Okay, it is showing all the elements in this stack. Okay, in this stack called nums. So this is the inbuilt stack that is provided by the Java. And if you also see what is nums.pop also, that's so you don't need to pass any value, because automatically this pop will pop the topmost element. Here the topmost element is the last, that is the 35. So 35 will be popped. So I will be writing here, so in the comment, so this will be popped because you are pushing this element at the last. We already know the stack is the LIFO. So you can see we are having 5 and 70, but we did not have this 35 because it has been already popped from the stack. So you can also see what is there on the top. So nums dot, you can say peak. So this will be going to return the topmost element. The topmost element would be 70. If you print that, you can see it is wait, we are not returning and we are not storing. So I will say just print that. So I will be going to drag this up. I will be going to put here, and I will be going to remove this extra semicolon, and I will be going to again recompile and run. You can see it is returning the topmost element as 35. So why it is returning the topmost element as 35? Because so the topmost element as 35 because before here you can see we are popping here. So before popping only we are seeing what is the topmost element. So the topmost element is 35. So after popping that we are after peak, that means after seeing what is the top, we are popping that and we are printing the nums array. So what if before popping I also print that, and if I see what is the thing, I will compile and run. You can see first of all it is doing peak with the help of this statement. So after that I am seeing all the numbers which are there on the stack, 5, 70, 35. So after that after pop that I am seeing 5 and 70. So this is the inbuilt stack provided by the Java. So I am not going to use that stack, so it will be remove that import also. Okay, that's fine and good. Sorry, what I will be going to do is, so the names will be same, so I will be going to remove up to here, or I will be going to show up to, so I am removing up to here. Basically this will be, I will remove this import as well. I will remove this import. Why I am removing that import, I will say because I want to make the custom stack. So if you hover over that, you will be going to have an option called quick fix. So click on that. It will be going to say you create class stack in package Java. So simply click on that. It will be going to create a file for you called stack.java. So inside that you are going to have clean this. Okay, so for your understanding I will be going to show you inside like this. I will be going to cut here. So I will be going to close this one also. So now you have a clear picture. Now we do not have a function called push. So basically inside this tag, so what I will be going to do is I will be going to say, so void push. I will be going to create a function called while push. It will be going to accept a data. Okay, you can see the error has been vanished because we are dealing now in the same package, demo.java and stack.java. So I will make this class will as public because both are interlinked. From this only we are going from here in the demo we are going to call the stuff. So I already mentioned there are two types to create your own stack. First of all, with the help of the array. So basically in the outside I am having a variable called array. So inside this array I am going to store the file elements. So that's the default, that is your wish. So I am also going to have another variable called top. So I will just initialize that, and I am going to have just the size. Okay, these are the three variables that I am going to use in my stack, my own build stack. So inside this push, so what you can do is, So before that, what you can do is you can create a constructor. Whenever you create an object, that this constructor will be called. So you can say public, so constructor name would be stack. Okay, so inside this constructor you can mention the size would be same as the array dot length. So that would be size would be 5. So after that, what you will be going to do is you are going to have the default top as is equals to -1. So I am going to initialize the top with the -1. Why? If you come here, if you come to my slides, so inside the slides you can see clearly. So before pushing anything, so there is nothing in this tag. So what you can declare there, what you can see, or what you can pick, that what you can pop. So for that reason only we are going to initialize the top, this top variable, to the bottom. So by default the array indexing starts with 0. You are not going to have the index 0. So you are going to say the top as -1. So in the top we have -1. So after that, what I am going to do is I will be going to say, so void push function. Inside this we are accepting some data. So as we have already have the top, so we can simply say top plus plus. Okay. After doing top plus plus, you can have one condition, that is if. So you have a statement, if statement. Inside that you are checking the top and size. If the top is greater than, if the top is greater than -1, you can see here, it is nothing means it is initialized with 0. Here top is -1, but the top is initialized here to the 0, because -1 plus 1 is 0. So the top is greater than equal to size. Yeah, in this case it is true, because the top is 0 here, the size is also 0 by default. Now inside the statement you are going to say we have an array called array. So inside that you are going to say the top. So we are going to say allocate the data of the data, that what we are accepting here. So don't forget to place the semicolon. So this is the thing that we are going to have here. If you fail, so if this condition fails, if the top is that, so then inside this you can just simply say print something in the terminal, that is stack overflow. So the next we can call the public. So we can create a function called show stack. So what this function will do, basically this function will be showing all the stuff, what are the all elements in there in the stack. So basically we can call this function, so with the help of the nums object. So nums dot show stack. So inside that we are not going to accept anything. So like this, in this situation you are going to pass the stuff, you are going to call this method here. So inside this, what you are going to do is you are going to have a for loop. So inside that, it's not normal for loop, it's for each loop. So inside the array we are going to able to traverse that. So inside this you just print the n value that we are giving here, and you can also append with some spaces, so that it will look nice in the terminal. Okay, if you see inside push only we are declaring this method. So simply from here to here you can take out that. So in the outside you can paste that method, so it's not illegal now. So I have just made a small issue that, so I am declared this method inside this only. So make sure that you are declaring in the class. So in the stack class you need to declare, not in the push one. So you basically are able to see what is the values in the show stack. So here we have make a small mistake, that is top which is less than or equal to size -1, because here you can see here the size is where initialized is 0. So but first of all we are make sure that size should be -1, then top we need to compile in this fashion, and after compiling you can see it is showing the correct result. So 5 and 20 and all remaining 3 would be initialized with 0. So you can see the push, we are pushing 2 elements, that is 20, and we are having the function called show stack. So with the help of the show stack we are printing all the stuff in the terminal. Now what I am going to do is, I hope you understood the fashion. So inside the stack class we are having functions called push function, we are having function called show stack. So similarly we can have the function called peek function, we can have a function called for the pop. So I hope you understood the pattern, that how I am doing. So these are the three stuffs I am having, two stuff. So I hope you know the push. It will be going to push all the elements to the stack. So I hope you know what is meant by show stack. It will be printing all the stuff in the terminal. And then next we have the pop operation. So this pop operation will pop the elements. So you can say, I will explain. So in pop, so it will not accept any argument, because just popping the elements, no need of any checking. So here we are checking if top is equals to -1, means is there any element in the top is equals to -1, is there any element? If this is the case, we should say stack underflow, there is no element in the stack, we should simply return -1. Or you can simply say if there is any element, you can simply say array of top minus minus. First of all, it will return the element, it will return the popping element. In this case it will pop the 5. If you here it will if you system.println. I hope this makes some sense now. See, you are calling nums.pop. It will be going to call this function. Inside this, we are printing that stuff. What is it returning? So as the last in first out, the stack is the last in first out. It will be going to pop this 20, and it will be going to return you 20, and we are printing that 20 here. Okay, let me compile and run. So you can see we have 20. So you can see clearly we have 25, and finally it is also printing the 20. Why it is again printing 20? Because this is the first one we are printing is the pop element. If you want to confirm, just I will be going to reverse that, and if I again recompile that, so you can see first of all 5, 20, these two are printing because of this this statement show stack, because it will be going to show all the stack elements, and next we are calling this nums.pop inside here. So due to that, it is at the last rate we are printing 20. And what is this peek operation? We already seen peek means to see the topmost element. If top is equals to -1, that's the case, then say that stack is empty, and return -1. Otherwise, just return the top. That's it. Means we are seeing the top. That's it, right? So if you want to see what's the top, so after popping this element, you can simply you can call here with the help of this thing. So inside it, you can call nums.pop, or sorry, nums.peek, because we already did the pop operation. So if you compile and run, you are going to say 520 because of this show function, and pop because of this returning element 20, and peek what is now current top, that is 5, that is printing successfully in the terminal. So I hope you understood stack implementation with the help of the array. Now we are going to understand the stack implementation with the help of the linked list. So in the previous sessions we have already discussed about linked list. So as the same as the linked list, as same as the stack, so mix both of them, you are going to get the implementation of stack with the help of the linked list. So there is nothing complicated. I will just explain what I did here. So you just need to have another class here for the node to create each and every node. So we have data and the next pointer in the node. So after that, I am creating a constructor here. So inside that we have int data. So we are by default value passing here whenever we create a node. So by default pointer will be, the next pointer will be of type that is null. So whatever the stuff happening here inside the stack class, so the stack class we are able to successfully call from here. So inside this stack class we are introducing the type safety also. There is no issue in that. So if inside that we are having a top pointer. We already discussed in the linked list that we should have a head pointer. In the similar way, in the global level of this class, we are going to declare a variable called top of type node. Okay, the type node. Here you can see node. So after that, you are going to have a constructor. Whenever you create a new object of the type node, you are going to call the stack, and you are going to initialize the top with the null. So after that, I'm going to push the values with the help of this code. So if you see clearly, we have public void, the same as the functions that I have created before, but it's with a small change as they are implementing here with the help of linked list. So you can see we are creating a new node. Here we are creating a new node. Okay. You can see clearly here we are creating a new node. Whenever you create a new node, this constructor will be called, and the next pointer will be initialized with the null. Okay. So after creating a new node of object, or after creating a new object of the variable called new node, so inside that we are going to assign the top. So after that, what we are going to do, we are going to assign the top to new node. Okay. If you see in the presentation, that is very important. We are assigning this, here head is known as the top. So whatever we are doing, we are going to push all the values to the bottom. Okay. So first of all, we need to push from here. We are creating a function for pushing right. So to push, for what we are going to say is top dot next is equals to, if you see in the code, the top, we are placing the top in the new node dot next. So we are placing this top at, this is known as new node dot next. Okay. And whenever you come across the next suppose this the top at this position, then we are going to apply the push operation in this side. So what is meant by that? Basically this next will point this side backward. So this makes some sense now, right? So you can place the top value with the help of the new node, and we can print the data whatever is there in whatever we have pushed the data. If you see the direct code, you might not understand. Try to see this with the help of the diagrams so that you can understand. Okay, I already explained before, the push and pop operations will be happen with the in the side of the top side only, in the head side only. So in this I am going to display all the stuff with the help of the top pointer only. So you can say I am creating a temp pointer with the help of the temp pointer. I am going to, with the help of while loop, I am traversing all the linked list. I am printing all the stuff, with the help of this temp pointer. Okay, I am in this demo.java. I am just pushing 5 and 20, and I am seeing all the values. You can see. So it says 5 is pushed and 20 is pushed, and you can see the values because we have called here nums.show. We can also have the pop operation, the peak operation also. I will also show that now. So as you can see, these are the two operations, that is one is pop operation and one is peak operation. In the pop operation, what these are not much important, so that's why I'm just quickly writing the code and explaining to you. So if you see the pop operation, we are just comparing the top with the null. So after that, you just printing the stack overflow, because if top is null, there is no element in that, right? So the return -1. If there is value, just come out of this and you are going to have value. So you are going to store, because the return type is integer, and suppose suppose if I say come here, so I can simply say the system.println in this, so I can call so nums.pop. So basically this pop will return an element, and thus we are with the help of this object we are printing that element. Okay, so yeah, we will see that. Before that, what I will be going to explain this code. So we are storing this value inside this, and finally we are returning that value. So what is meant by this peak operation? It will be going to show. So we are seeing is the top is equals to null. If that's the case, then we are going to say the stack is empty and return -1, because here also the return type is integer. And finally we are returning the top data, because we are returning the type safety also we are introduced, that is integer. Okay, so now what I said is, here we are seeing with the help of we are printing the pop element. Here we are seeing the topmost element with the help of this peak function, because we already make the peak and pop operations with the help of the linked list. Now if I compile and run, here you can see clearly. So 5 is pushed first and 20 is pushed. Then we are seeing the operations with the help of this store stack, and finally we are having the 20 and 5. Here 20 represents the peaked value, popped value. You can see. If you want, you can also append with the, and in this fashion also you can copy here and you can paste peaked element, peaked. So in this fashion, if you compile and run, you can see with the clear text also what is the popped element, that is 20, and what is the peak element. So in this fashion, how you implement with the help the stacks with the help of the linked list, and also you have understood with the help of the arrays as well. So try to understand this code. So I hope you understood how to implement the stacks with the help of arrays and queues. So thanks for watching up to now. So in this session, we are going to understand what is meant by queue. So in the previous session, we have understood in detail about stacks. Now just the opposite or a just slight modification for the stack is known as queue. So queue have many uses for booking a ticket, or if you're in your airports, or somewhere if you see in movie theaters, you can see a queues where the people stand in a queue, and they will collect the ticket and come out first. Means whoever go first, they will come first outside. So that is known as the queue. So that is only written over here, the first in first out principle. And the stack is the pile of books, if you can observe as the example. For the queue, you can take an example like standing in a line like that. Okay, so that is the first in first out principle. You can see we have two pointers known as front pointer and rear pointer, and we can have two operations here, that is NQ and here NQ and DQ. So basically these pointers are very important, because as we are taking the inputs from the back, from the back, so to reduce the complexity, we are going to have the rear option. So with the help of this rear, we can simply append the elements that are coming in faster, and we can simply DQ them. Means we can simply pop in the terms of stack. I can say we can simply pop. So that is known as the DQ, but we are doing with the help of the front variable. Okay. So this is the simple diagram. Also you can see over here we are enqueuing from the back and we are dequeuing from the front. So these are the simple two terms, and you can also take the other two terms also, front, rear, NQ, DQ. So these are the four terms, important terms in the queue that you need to remember always. So if you see further, these are the stuff. We also already know what is meant by NQ. Adding a new element in the 10, that will be from the rear end, not from the front end. So if you want to DQ that, you are going to do from the front end. So as like we have seen in the stack, the queue also can be implemented with the both array as well as the linked list. So if you see the first in first out for the stack, and the first in first out for the stack, that is for the queue, and last in first out for the stack. The same thing written here also. So if you see in the Java inbuilt options, we have the offer and pull. So here we need to understand very important concept. In the stack, that is push and pop for insertion and deletion, but in the queue it is somewhat the terms are opposite. So the terms that we need to by heart by ourselves, we can't do anything. So the first implementation that we are going to see with the help of the inbuilt Java classes, that is the offer. Offer means insertion and element. So the next one is pole. Pole means to remove from front, remove front element. Okay, peek means view from front element, and is empty means check whether the queue is empty or not. And finally is queue is the queue size means the number of elements that we are going to. So in my VS Code, just I am trying to demonstrate with the help of the array. So or in this is basically with the help of the dynamic array. If you are using see this line, what is this line meant by that? So first of all, I will be going to show how to use the queues with the help of the inbuilt classes by Java. So we are creating an object called queue. So with the help of this object queue, here you can see we are creating new linked list, and we are also introducing the type safety of integer. So here we are performing the enqueue, that is known as with the offer. Already we have seen what is meant by offer. So offer here means to insert an element or to push an element, let's say. So in the stack, if you in the terminology of stack, I can simply say to push an element into the queue, that is here known as offer. So you are pushing 10, 20, 30 with the help of this object queue dot offer. You are pushing all the three. So after that you are going to push like after pushing all this stuff, you are going to see what is at the top. The top element is that 10 because this is the queue. The front element is known as the top element. After that the pole means you are going to remove the topmost element. You are going to dequeue that. So this is known as the dequeue. So the 10 will be removed. Why 10 will be removed? Because here it's as a queue, the topmost element, the front element will be removed from the queue. So finally we are displaying all the elements. It will be printing 20 and 30. So if I compile and run, you can understand very clearly. So it is saying front 10 from this line because it's seeing what is the front element. So it is saying removed 10 because that element 10 is in the front element. Okay, it is removing very clearly. So finally we are seeing what is the elements are present inside the queue. So it is saying 20 and 30. Now you can see clearly 20 is in the front and 30 is in the rear end. The front is pointing 20 and the rear is pointing 30. Again, if you perform the pole operation, let's see what happens. So I already performed the pole, but I am again performing the pole. So let's see what happens. If I compile and run, so you can see it is saying removed 10 and removed 20, and it is showing one element in 30. Okay, that front, rear, and that all things will be pointing now only for this 30 only now, because the front, rear are combined and pointing to 30. Okay, as why it is 20 removed first? Because this is the queue, the first element will be removed as this comes first. So we already know queue is a first in first out philosophy, it follows. Now we will also understand, we will not use the inbuilt packages. Okay, I am going to remove this stuff here. So I am going to remove this printing song. Okay, let it the printings be there. So it is showing error. So if you hover over that, you can see quick fix. So if you hover that, you can see create class queue in demo. No, I don't want that. Create a queue in package. So just click that. So basically it will be going to create a file, another file for you. Inside that file, it is also accepting the type safety. Here inside that we are going to have all the stuff. So again it is showing error because we are not having any functions called offer and peek and pole. So inside this queue, what I will be going to do is now, so in the demo I will be introducing one by one stuff. So I will be going to remove all the stuff from here. So this linked list is also not there. So we can also typecast this to queue type. Okay, now it's very perfect. So we are creating an object of queue that we have created in this. So we can make this class as public so that we can use in that class, in this demo class. Okay, so in this queue class, what I will be going to do is I will be going to implement with the help of the array. So for that purpose, I am going to have the variables front and also, or front rear. So I am going to have that variables. So this is the integer array. Okay, we are storing all the elements in this integer. So currently it is empty now. Okay, so after that we have a variable called front and we have a variable called rear. We have already seen in the PPT, and we have a variable called size. So we have a constructor. So public queue. So what inside this we are going to initialize the size 5. Okay. So that's your wish. You can initialize the size according to your requirement, and we are going to initialize the size here. Okay, so basically this integer array will be of size 5. After that we are going to assign front value as 0 and rear value as -1. Okay, so after that I am just performing the enqueue operation. In the enqueue operation you can see we have the enqueue. So you can also change name as to offer, but as for our understanding what we understood, so that putting element is enqueue, removing element is dequeue. So it's not inbuilt given by Java. We can modify our names. We can modify our function names. So that's for understanding purpose, I named it as enqueue, not rather than offer. Okay. So after that, what I will be going to do is I will be going to check whether the rear or whether the last pointer is the size -1. If that's the case, we are printing stack or queue or floor. So then we are returning 0. If the array is equals to size 9, if that's false, then we can simply say that array plus plus data, and we can simply print that data has been inserted. We can say the data has been inserted in this array. So let's quickly come to the demo, and inside this demo I will be going to say with the help of this q. So say q dot enq. So inside this enq we are going to pass data as 50. That's your wish. So inside this q also you can see we have a function called enq. We're accepting integer called data. Now if I compile and run, if I again come to demo, if I again pass and the 2 3 variables, okay, if I say this as 25 and if I say this as 99 or 92 or something, if I again compile and run, see it is saying 50 is inserted, 25 is inserted, 92 is inserted. So basically we are successfully created a function called enq which can insert all the stuff into the array with this array arr. Now we are able to make this enq. Now we will make dq, peak, and the other functions as well, so that you can understand how we can inbuild the q. So now if you observe, I have made two functions. One is called dq and another is called peak. So in the dq, basically this will remove whatever the element that you means whatever the element is at the front, that we have understood from the slides also. Now inside this dq function you are checking that whether front is greater than rear. If that's the case, you can simply say under flow and return -1. So after that you can just return the array of friend plus plus. So this will be going to remove the frontmost element, and it will be going to return what the element that has been removed. Okay, so the same stuff as the stack only. In this peak value you can simply return the value at the front. So here inside if statement I simply have a checking thing. So I will simply come to the demo file. Inside this demo file we have just enqueued now. So I will also show how you can do dq. So for that I will say system.print. Inside that I will say dqued element. So after that I will be going to append with the nums.dq. That's it. Here, not nums here. In the stack we have used. So here the object is q. You can say q.dq. Now if I compile and run, so you can see we have inserted 3 elements and we have dqed element 50 because it is at the front and this 92 is at the rear. Now if you want to see system.error, not system.out, that is okay, there is no issue in that. And if I copy this statement and if I say peak, because we already make the value for the peak, so you can simply remove this dq from the here and you can say peak here. You can call peak function with the help of object q. You can compile and run. If you see we have 50, 25, 92 inserted to the array, and we have dq'd 50, and we have seen what is at the top. After removing the top front element, now 25 is at the front, so 25 is saying it is at the front. So we understood what is enq, to enq the element, what is dq, to remove the element at the front, and finally peak, to see what is element at the front. And finally we can also display all the elements what are there in the queue. So you can see clearly with the help of this display queue function, we can simply see, show queue function. Check just this is a normal check whether this front is greater than rear, only we are going to start our work, otherwise we don't start work. So you can see this kind of checking is there in the peak, this peak as well, and this kind of checking is there in the dq and in the enq also. So checkings must be there, otherwise it will be going to throw you errors or exceptions in Java. Okay, that is array outbound, array inbound, or array underflow, stack overflow. That kind of errors will be shown to you. So that's the reason you are going to have these kind of checkings. After that checking, so you are going to run a for loop. Inside that you are going to print all the stuff what is there inside this array. So quickly I will come to the demo, and after this picking and dequeuing, I will be going to call with the help of this object. So I will be going to call show queue. That's it. If you compile and run, we have 25 and 92 elements in the queue because we have already dequeued the element here. Okay, 50 is removed and we are having only 25, 92. Those are printed in the terminal. So I hope you understood how the queue is implemented with the help of the array. The array here that we have declared here is the array. So I hope this makes some sense. So enq, this is dequeue. Finally we have peak and show queue, and that's the functions. Hi guys, welcome back. In this session we are going to understand what is meant by trees in detail. So in day-to-day life we will be going to operate file system in our computer. You can see the file system here. So basically you have a root folder. Inside documents, pictures, you have separate folders. So inside the documents you have working folder, you have personal folder. Inside the pictures also you have some picture, and you have some family folder. Inside you have some family, pictures, personal. Okay, now inside this work you have some files, separate files. So this is the way how you organize your file system in your laptop, okay, or in your desktop. So in the similar version, if you want to represent the same stuff in the format of this a tree, So this is known as a tree. Okay, this structure is known as a tree. So this is the hierarchical manner how you represent the data. Unlike the stack, array, linked list, these kind of structures are known as linear structures. Those will be in the straight line, but the trees and graphs will not be in a straight line. That will be hierarchical and it will be a non-linear structure. You can read over the definition of a tree here. So a non-linear structure, a hierarchical data structure used to store and organize efficiently for operations like searching, insertion and deletion. Okay, unlike linear structures like array or linked list, trees have a branching structure. So yeah, in regular life we see the trees like. So the same way in the programming language concepts also we name it as trees only, because we have one root, it is like a tree, so that's why we name it as a tree. We have branches coming down, so it's branching structures we can understand. So if you can see clearly over here we have a data structure. So basically now I am explaining what is the structure of the tree with the help of this tree diagram. Yeah, the tree is explained with the help of this tree only. So the data structure is there. We have two types, linear structure and non-linear structure. In the non-linear structure we have trees and graphs. In the linear structure we have static and dynamic. So static we have arrays, dynamic we have linked list, stack, queue. So already we have covered these three concepts in the previous sessions. Please see that. So if you see clearly in the trees we have each and every important concept that I am covering here. So we need to understand some of the related terms here in the trees. So we have node concept. So what is meant by node? So each and every node which contains three parts, which is data, left pointer, right pointer, is known as the node. So what is meant by root? So basically the topmost node or the no parent, which has no parent. This is known as the root. You already see in this structure the which has no parent. So you can see document has a parent, which is the parent root. Pictures also has a parent, which is the parent root. But root does not has any parent. So that is meant by that this root this value is known as the root ultimate one. You can also see the working folder has a parent called document. This family folder has a parent called this picture. So in a similar way, so the root is meant by that only. So the parent and child roots are represented by this. So this picture folder represents the parent and this family folder represents the child. So you can see with the definition as well. Okay. The leaf nodes that represent the bottommost elements which has no children. If you see clearly over here, the bottommost, if you see this file, the project.b.java, which do not have any children, this is known as the leaf node. But working folder has some two leaves or two children. So this is known as parent, this is known as the child, but it has also other name called leaf nodes. So this is known as leaf node, this is known as leaf node, this is also known as leaf folder, this is leaf file, this is leaf folder. Because this working folder is not a leaf folder because it has two child. The bottommost elements which do not have any children is known as the leaf nodes. So you can see this thing, this are known as leaf nodes. So height and depth are known as the what is the length of the tree, what is depth of the tree, and what is the degree of a node. So the count of its immediate child nodes. So the number of child nodes is known as the degree of the tree. Degree of a node. If you see clearly over here in the diagram, so you can observe all the stuff in a single image. So this is known as root. So the root node will be in the position of level 0. In the next level is known as we can have two elements if this is the binary tree. Okay, only a single parent can have two children in the binary tree, because that binary means 2. So single parent can have only two children. So this is known as level 1. So after that B has 2 children, C has also 3 children, as this is not the binary tree. So parent node, this is parent node D, which has 2 children. These are known as child nodes, and this complete tree is known as the subtree. So I, J, K, F, G, H, these are all known as the leaf nodes, because these I, J, K, F, G, H does not contain any further nodes, further subnodes. A is known as the root node. We already know about that. So see clearly, if you want to understand what is meant by degree of a tree, so you can see with the help of this simple GIF. So you can see the C node tree has degree 1. Why? Because it has only 1 children. Now you can see all the leaf nodes has degree 0 because that does not contain any children. So A has degree 3 because it has 3 children. So B has degree 2 because it has 2 children. C has degree 1 because it has only 1 child. So in that fashion, you can see again this animation. If you want to see animation clearly, you can also pause the video and or go back through the video and see this animation clearly. So whatever the node you are there, it has showing the degree of that node. So C has 1 degree. So all the leaf nodes has degree 0, and root node have degree 3 because it has 3 children. I hope this makes some sense. You understood now. So how to create a tree, or how to know whether it is a tree or not. So I have explained already what is meant by the node. So node is a ultimate thing. With the help of the nodes only you are going to create a tree. You can see how to store the data or values. Okay. In the left side we have the previous node pointing data, and the right side we have the right side pointing data. Currently this is the node. Inside this we have some data. In the right we have right pointer. In the left we have the left pointer. So, sorry, this is the right pointer, this is left pointer, currently initialized with null. You can see with the help of this class I am going to create the int data, means this data node which is a pointer. I am naming it as the left, means this one. So node which is a pointer, and I am pointing to the right, which means this one. Okay, in this fashion you can create a node. Now you understood how to create a node. Now I will explain how to create a tree. So basically with the help of that nodes, so arrange all that nodes here like this. So basically this node having null. So you can see all of arranged like this, which are having data null. So you can see I am this is the root node. So in the root node, the left pointer I am taking 105, means this pointer. This 105 is pointing here. So 110 is pointing here. Okay. 115 is pointing here, 120 is pointing here, 130 is pointing here, and 140 is pointing here. And these are leaf nodes which does not have any further children. So you can leave the left pointer, right pointer as null in each and every leaf nodes. Okay. So this is the complete tree in the Java. So you can see, if you want, you can also represent in this fashion, in these lines also. But ultimately, if you want connected with the help of the left and right, that's it. That is logically connected. But if you also see the visual representation, this is the visual representation how the trees are connected. We can also understand with the help of the code as well. In this video only, we will be going to see with the help of code. I will be in detail explaining the code. Okay. So before explaining the code, let's also understand what are the types of the trees in every language. Basically, you are going to see these things in every language, like C, C++, Java, Python. Every language you are going to have these kind of structures only. So you can see the types of trees. We have binary tree, binary search tree, full binary tree, complete binary tree, perfect binary tree, balanced tree, and finally skewed tree. So what are these types of trees? You can see clearly over here. You can pause the video and you read it by yourself. You can understand, you can get to know about these simple structures. Okay. So there are 6 types of, you can simply say that. So you can say that every node has either 0 or 2 children. That is known as, or you can say no node has only 1 child. Okay. That is known as full binary tree. Okay. This is the thing. So you can see that every node has 0 or 2 children. You can see this parent has 2 children. This parent has 2 children. This one has 0 children. You can see it is following this rule. And this children has 0 children, so this is accepting this one. Okay, this node accepting 2 children or no children. So if you see the complete tree, it is saying that all levels are completely filled except the possible at last level. So you can see that the last level is filled at the from the left to right. Okay, so you are going to start filling from this side. So first you fill left, fill right, fill left, fill right, fill left, then stop if you does not have any elements. So don't fill the right first. Okay. So what is meant by perfect binary tree? So all internal nodes have 2 children. Okay. It has 2 children. It has 2 children. It has 2 children. This is known as perfect binary tree. All leaf nodes are at the same level. You can see all leaf nodes have at the same level. So what is meant by balanced tree? So this balanced tree is also known as AVL tree. Why it is known as AVL tree? That is known as because we will see that in the upcoming sessions. So degenerate means the random order. So binary source tree, this is very important thing. So here 5. So in the left side it has to be the small number. In the right side it has to be large number. You can also read all the definition in the complete details by pausing the video. So binary tree having at most 2 children, full binary tree having 0 or 2 children, complete binary tree completely filled, perfect binary tree having 2 children or leaf node. Okay. So in this all the stuff, this binary source tree is very important because the left subtree has the smaller values than the root node, and the right subtree has the greater values than the root node. So other than this, we have something known as heap tree, AVL tree, red black tree. So you can also see the same stuff here also. So I explained degenerate. So I explained what is meant by complete. So full. So complete means you are going to start filling left, right, left, right, left. So full means you are going to start left, right, left, right, left, right. But there is no compulsion that you are only need to fill from the left, right only. You can also fill wherever the position you want, but compulsory you need to have 0 or 2 nodes. So in the balanced also, that is AVL tree. In the perfect means all the stuff has to be in the same level and same number of nodes should be there. Okay, and 2 power n nodes should be there. Okay, 2 is there, 2 to the 2 power 2, which is 4. But in this case, that's not the case. Here already you have completed the 2 power 2, but here you need to get 8 elements, but here only getting that 4 elements. So this is the difference between full binary tree and perfect binary tree. Now we have understood what is meant by the complete, full, degenerate, these and all stuff. We understood what are the types of trees we understood. Now we should understand what are the traversal. What is the traversal? Because you have created a tree, but you can, how you can see the what is the elements in the tree. So how you can see the elements in the tree, that is with the help of the traversal. Basically you have 3 types of traversal and other 2 types of traversal also. So in the 3 types of traversal we have something known as pre-order, we have in-order, we have something known as post-order. So let us understand what is meant by pre-order. So I will explain with the help of the shortcut. So you can see the blue dots. I hope you can see the blue dots. So each blue dot you can see, that is known as pre-order. Okay, you can see the ultimate order. So the ultimate aim is to print all the stuff what is there in the tree. You can have to print that in the terminal. So that is the ultimate goal. So with the help of the simple stuff, you can see we are going to check whether root is equal to null. No, it is not equal to null because we have some stuff A here. So we are first printing the data because we are at the point A. You can see blue dot. Blue dot means print. You can see system.println means print. You can see with the name itself. Pre means print. Pre means left side. You can see print. So print. You can see A, B, D is printing. A, B, D is printing. Next H is printing. Here you can see H is printed. Next come. You can, whenever you see the blue dot, print that. So you can see blue dot means I. You can print that. So next come. You can see blue dot E. Print that. So I'll come in this fashion. You can see blue dot C, blue dot F. Print that. C, F. So like that you can come like this here. You can see the blue dot on G and G and J. You can print G and J. So you can achieve with the help of the recursion. First you need to go towards ultimate right, ultimate left. So you can see we are going to ultimate left. So you, after that you are going to ultimate right. So you are slowly going to the ultimate left, right. First you are going left. After that you are going right. So this is known as pre-order. So in the same fashion, if you want to print in the in order, so wherever you see the green dots, that is known as in order. So you can see first if you want to go to all traverse and you have to print the stuff, you can see in the code as well. So first of all you need to traverse all the stuff towards the left. So after that you need to start printing with the help of these green dots. So H, D, I, B, E, A, and come here F, C, J, G. You can see in the help of the same order that I am saying here. You can also compare the stuff green dots and here also the same order. Okay, ultimately you are going to the right. First left, print the stuff, go towards the right. Okay, so the last and final traversal is post traversal. So you can see what is meant by post traversal is wherever you see the orange dots. So pre traversal means the left side. So in order means the underneath of the node, and so post traversal means the left or the right side of the node. Okay, the post, the right side, orange node. So you can see, so come here, the orange node seen here. So H, so after that H you can see I here. So you can follow the arrows how I am following. So D we have, E we have, B we have. So come here, F we have, J we have, G we have, C we have. So finally we are printing A. You can see the same order that what I have said now. So by seeing this diagram you can simply understand what is meant by pre, in order, post order traversals. So you can say why these orders are different, because the ultimate aim is to print something in the terminal. All the elements has to be printed in the terminal. Whatever the logic you follow, whatever the way, whatever the order, that doesn't matter, but you need to print all the stuff in the terminal. So you can see first we are going that left, and next we are going to the right, and after that, so left, right, print, left, right, print, like that, left, right, print. That's the stuff. So finally we have something known as level order traversal. In the graphs we will be going to use this level order traversal. As the tree is also a graph part, you can see we have 2 types of level order traversals. One is BFS and another is DFS. So what is meant by BFS? So BFS is you can follow the arrows. So breadth wise we are able to printing. So the level 1 first we need to print. After that level 2 we need to means level 0 we need to print first. Level 1 print next. Level 2 print next. Okay. So if you want to see the output, I will reading words, you can see the output here. So you can see for it print the level 0 first, that is 0. Next print level 1, that is 1, 2, 3. Next print the level 2, that is 4, 5, 6, 7. So basically this is the tree. In the BFS breadth for search, so you are going to print 0, 1, 2, 3, 4, 5, 6, 7 in the level wise. Okay, you are going to follow come in this fashion. But in the DFS depth first search, how you are going to print is you are going to print the level wise. So okay, ultimately the orders may be different. You can see the output is different here, output is different here, but ultimate A is to print something in the terminal. Okay, something means all you need to print all the stuff with the help of some logic. You can go up to the depth, you can go up to the breadth, that is your according to your wish. Okay, so if you follow the arrows, so you can see first I am printing 0, next 1, next 4, come back 5. So go back, so you are going to print 2, you can see 2, then 6, go back, so you are printing 3, you are printing 7. So again see the stuff here. You can follow the arrows while I am reading this stuff. So 0, 1, 0, 1, 4, okay, 0, 1, 4, 5, 2, 6, so 0, 1, 0, 1, 4, 5 here, coming back, so 2, 6, okay, next we have 3, 7, so come back 3, 7. So this is the complete tree, complete pack. Now we are going to unpack. We need to see the code so that we can understand in detail about how to create a node, how to manage insertion, deletion of each and every node. Okay, currently now I am in my VS Code. So in my file called demo.java, inside this I have inside this class demo we have a main method. Okay, now inbuilt there are like, let's say, okay, let me create a binary search tree for you. So in this code we are going to create a binary search tree. We have many trees we have seen. So out of all those stuff we are going to create a binary search tree, because the left side of the data will be less than the root node, right side data will be greater than the root node. That's the thing that we are going to create. So what I will be going to say is, I will say binary search tree, and I will be going to create an object, and I will be going to say new, and I will say binary search tree. Okay, this makes some sense. I hope you know how to create this object. Okay, I am creating a reference object of binary search tree, and I am creating a new object called for this class binary search tree. But you are thinking now there is no object, there is no class for this binary search tree. Yeah, there is no class. So if you hover over that, you can see quick fix. Okay, it will be going to show all the methods that you can erase this error. So you can say create a binary search tree in the demo. No, create class in binary search tree in package.java. Yeah, I have a package called Java. So package means here folder. So you simply, if you click that, so for you it will be going to create a folder called binary search tree.java. So if you come inside that, you can see clearly I will be going to erase this. So for your understanding, I will be going to take this here. Okay, I will be going to close this folder structure. So now you can see this both of the folders in a simple way, both the sides both, and you can see the terminal as well. I will write this afterwards. Okay, or I will close this first. So you can see we have two folders, that is demo.java and binary search tree.java. Now in this I am creating an object for this class. Okay, binary search tree class. So I will be going to make this as public. I will make this binary search tree as public, and in this we are creating an object. So we'll come down. So we will say bst. So for the object bst we are going to say dot insert. So I am going to insert some number, example say 50, but we do not have a method called insert. So I will come here. Okay, I will quickly come here, and I will be going to say public void insert. Okay, this will accept an argument, so I will say int value. So after that, open the braces. Inside that you are going to say root is basically we did not create the root, because we know that the tree execution will start from the root. So root is also a node. So first of all you need to create a class for the node. So without creating a node, how can you create a root element itself? So I will be quickly going to create a class for the node. So inside this we already see in the presentation that we need to have the data. Okay, we need to have data for the node, and we need to have the left pointer, and we should also have the right pointer. Okay, so I had both the pointers, that is left and right pointer. So I will come down, I will be going to say node. So it will be going to accept a value. Okay, it will be going to accept, basically I am creating a constructor, because for this reference of node I will be going to construct a constructor. So in this we are going to say the data is equals to value that we are accepting inside this argument. Okay, so this constructor will be initialized whenever you create an object. Say you are creating an object here. So whenever you create an object, this data will be gone inside this data, and after that you are going to initialize the left pointer with the null, and the right pointer also you will be going to initialize with the null. So I hope there is no issue in this creation of the node. So we have already discussed how to create a node in the PPT, and here just you are creating a constructor that you can able to have the values first ever when you create an object itself. So I will quickly come here, and I will be going to create a root itself, because all the execution will start from the root. Root is of type node. Okay, we are I will be going to create the element for root, because if you know the linked list concept, here in place of the root will be going to create a node called head, and that will be initialized with null. Okay, but here we are initializing the left and right with the null. Okay, because we have in the root node we have left pointer and right pointer, because we have the reference of the node. Okay, so after that, we in the insert, what we are going to do with the help of this value, we are going to insert inside this with the help of inside this binary source tree, we are going to insert these values for the left and right. Okay, so I will come here inside that, and I will be going to say root is equals to insert with the help of recursion. Basically, this is a function which will take a root value and which will take a value. Okay, place the semicolon. So this value is coming from here. So this root already we have created, but what is this insert recursion? So this insert recursion is a function that we have not created up to now, so we will be going to create that. So okay, so come a little bit down. So or you can quickly hover over that, it will be going to quick fix. So create a method. Okay, it will be going to create a method in the private sense. So just remove this line. So for simplicity, I will be going to show only majority focus on this code. Okay, now what you are going to do is inside this, so missing return statement. Okay, that is directly created, right? So the return type is here we are created node, so we are going to return a node pointer which will be root. Okay, so first of all, inside this recursion type we are accepting the root node. It is inbuilt. I just quick fix and get this value, so don't create that. Just we are what the value is coming, you can simply change that to current. Okay, so whatever the value you are accepting, the same value you are going to check is that null or not. So if that is the null, if the root node itself is null, what you are going to just say return new with the help of new keyword. You can say new node dot what the value you are accepting inside that, what the value you are accepting inside the value, taking the value. If the current node means what the root value is null, simply return a new keyword. Okay, so finally after comparison, you are going to compare as this is the binary search tree. After the simple comparison, you are going to again compare with the value that is less than equal to the current dot value, current dot data or value, that is your wish, because if you see clearly over here we are saying that is as data. So if you name it as value, you can name it as value, that is your wish. So inside this if statement, you are going to say so current dot right is equal to insert track. Inside that insert track, what we are going to pass is current dot left, and we are going to pass the same value. And okay, this is for the left subtree, and in the same fashion in the else if also we are going to check for value. Is that value? I hope you know the concept of the binary search tree. The root node has to be the bit in between element, and the left subtree elements has to be the smaller elements, and the right subtree elements has to be larger elements. So the same thing I am comparing here. So is that value means the value that we are getting, is that the current dot data means this is the root node value. Okay, is that the value that we are getting from here, that is 50, is that equal or the less than the current node value? If the current node dot value is greater than the value that we are getting, okay, getting here we are 50. If 50 is the small value than the current data value, just place that value in the root left side. If that is greater, here that we are going to check with the help of this statement. So we are going to say current dot value or current dot data. Okay, if that's the scenario, then place simply this statement only. But sorry, here we are going to say the left, because we are placing this data in the left only, right? So copy this value and place it here. So inside this we are going to say the right value, because this is for the right subtree. Okay, change here also. So finally you can return the current pointer. That's why it is showing the error here. You can see over that it will be going to say missing return statement. Okay, you can simply you can return the current. This will be going to completely complete this function insert rec. So recursively it will be going to check whatever the value that we are inserting with the help of this function. So this insert will call this insert recursion. So inside this insert recursion, it will be going to check all this stuff and it will be printing in the stuff. So basically, if you see clearly, what I did is after creating this insert recursion, so I created two functions called, one is for the in order and the second one is for the in order recursion. So we already know about the in order recursion or in order, pre-order, post-order. In this video, I am going to show with the traversal with the help of in order. Okay. So in this in order, just I am going to call this in order recursion and I am passing the root value, as this is the global thing. So after that I am printing a separate line. Okay. So after that I am in the in order recursion, I just checking is the root is equals to null. No, if that is the case, So simply you are going to return. If that's not the case, you are going to first traverse to the left and you are print the data, and next traverse to the right. Sorry, this would be right. Okay. So in this fashion, first traverse left, print the data, traverse left. So you can see in the demo, if I come to again to demo.java here, so I have inserted one value and I am printing in order traversal. If I compile and run, you can see it is saying in order traversal and printing the value. Why it is saying that? Because I am printing in order traversal and I am calling the in order here. So this in order will call in order recursion. This in order, in the in order recursion we are printing the data, current dot data here. Okay. If you try to insert another data, let's see. If you try to insert so much data, so this is the data that you have inserted. Now let's see what happens. So if I compile and run, so you can see it is printing all the in order traversal data. You can see it is printing 12, 50, 250, 49. So it is printing according to the order that you not inserted. It is not the linked list. It is not the array. It is basically the stuff that is what we have understood according to the theory. You need to revise to the PPT and you can check what is the order it is printing here. The inserted order is not equal to the order that is printing here because this is in order traversal. See, we are inserting 12 at the last, it is printing 12 at the first. So that's not the case that you are inserting 469 at the last button, but it is printing at the last. Why it is printing at the last? Because due to in order traversal. So the concept you can revisit that, or you can have a graph inside that, and wherever you touch the bubble, basically the circle, wherever you touch at the bottom, that is the in order traversal. You can see here also. So travel up to the left, print the element at the bottom, or touch the element at the bottom. So finally go to the right. So you can also see here, first of all go to the left and go at the bottom, you can touch with the green bottom. So H, D, I, B, E, A, F, C, J, G. So in this fashion, how the bottom green ball is touching, that is known as the in order traversal. And I hope you understood this video how you can traverse the whole tree with the help of the in order traversal. So the similar version, but these three orders will be interchanged. So you can see, so in the up to now we have seen the in order. So first you are going left, printing the data, going right. So in the pre-order you can just first print, go left, go right. So we are in the post order, first of all go left, right, print the data. See, this is the simple difference between the in order, post order and pre-order. So I hope you understood the full trees. So thanks for watching up to now. So now in this session we are going to understand what is meant by algorithms in Java. So there are many types of algorithms in Java. So first one is the sorting algorithm, next one is searching algorithm, next we have graph algorithms. So in this session we are going to understand detail what is meant by searching, sorting and graph algorithms. So if you observe, so what is meant by sorting? So sorting is nothing but how you arrange the order. If you have from ascending order, you have descending order. So these are known as sorting orders. And if you go to the Amazon, like there you can see the list like sort by prices, sort by the data uploaded, like that, sort by deals, like that you can see. So there we can use this algorithm to have a minimal price and a maximum price at the bottom, or you can have in the descending order as well. So there is a inbuilt method in Java that is known as collections.sort. With the help of this single line, you can able to sort all this stuff, and you can also have the array.sort. So this is not the thing that we are going to discuss in this video because it's a easy thing, but we are going to have in the DSA, that is in the with the help of the manual implementation. So we are going to understand what is bubble sort, what is selection sort, what is insertion sort, what is merge sort, and what is quick sort in this video. And if you also see in this video only, we are going to cover what is the searching algorithms. So for the searching also we have the inbuilt options provided by Java, that is collections.binary search, array.binary search. Basically this works on the arrays or arrays. So if you see clearly, we have for everything searching and sorting we have manual implementation. Why? Because in languages like C, C++ we have only manual implementation. Like majorly in C we have only manual implementation. So with that reason, in the consideration in the Java also we have inbuilt methods. With that sidewise, if you customize that inbuilt methods, you can also use this manual implementation. So you means beneath this, that is going to work with the help of these two methods only. So one is linear search and second one is binary search. So according to your use cases, you can use linear or binary. So linear will be used when the array is unsorted, and binary used when the array is sorted. You can see sorted over here, sorted array. And the next algorithms are known as the graph algorithms. So in the graph algorithms, when we need to use the graph algorithms. So we have to use these graph algorithms like when you have the trees, like graphs like that. If you have, you can use these graph algorithms. So what are these graph algorithms? You have breadth for search, BFS, depth for search, DFS. So we have the extra algorithms. So this is to use to find the shortest route, shortest path between nodes of in the graph. So critical prime algorithms. So used to find minimum spanning tree. So these and all things will be important algorithms when you go further ahead. So other types of algorithms also we have DP, that is dynamic programming. So if you see in the lead code or somewhere else, the important questions might be of using many important questions like MQs. That kind of questions will be based on the dynamic programming. So in this, what we will do, we are going to store the previous values so that we can use with the help of this memoization. It is not memorization, it is memoization. And we have some greedy algorithms, and we have some hashing methods also. With the help of hash map, we are going to have hashes. We are going to do hashing algorithms. So if you go further, so let's start with the searching algorithm. One is linear search and second one is binary search. So in the linear search, what is meant by that? So checks every element one by one suitable for small and or unsorted data. So assume that you have an array called nums. So you already know that the array will be indexed with 0. That is 0 based indexing, that is in Java. So as this is a searching algorithm, you need to search a given element, whether this element is present in the particular array or not. Suppose that you have an element like 6, we have to search in this array. Is that in this whole array, is the 6 is present or not? So if you observe manually, there is 6. So if you see what is meant by linear search is each and every index we need to go manually. So at the first index we need to check if that is not equal to 6, we need to go forward. If that is not equal to 6, we need to go forward. If that is not equal to 6, go forward. So at the index 3, we are going to have the 6, means if 6 is there, we are going to return that is true. If like that, if this is not 6, we are going to forward, then out of the array, so we are going to say false, the array is not present, the particular given target is not present in this nums array. So this is known as the linear search. So we will also see the code implementation so that you will be very familiar with the code as well. 9, 1, 6, 4, 2. So these are the elements that I have in the array. So after that, what I will be going to say is I will be going to have target. So I will say set the target as 6. That is your wish. You can set whatever the number you want. So first of all, we will check is this 6 present in this here. If 6 is there, we are going to return the index. So see, the index is 1, 0, 1, 2, 3. So that will be basically going to return us the index number. So after that, what I will be going to do is I will say this int result. Basically, this result, inside this result, we are going to call linear search. So I know this linear search is the function that is accepting the nums array, and it will also going to accept the target. So I know this linear search function is not made by me now. So I will made after I have the result. Means this linear search function will return us the index if the element is there. And or if the element is not there, it will be going to return us -1, and we are going to store in that result thing, because that seems simple. So if result is not there, if result is -1, because if this -1 is there, if this linear search returns -1, if there is no element in that, what we are going to say is we are simply going to print something in the terminal. What we are going to say is element not found. And the next thing that we are going to say is the else statement. In the else also we are going to say that if array is equals to -1, then we can have the opposite statement. But what I am saying is if array is not equal to -1, basically if array element not found, I am saying if element found, we can simply say element found and we can have the result here. Basically it will show the index number. Or if element not found, if a result is equals to -1, then we are going to say element not found. So this is a simple syntax. I hope you understood this. This is not that much tough. So after what I will say is after this main function, I will come down and I will if you hover that, it will show quick fix. Create a method called linear search, and in that we are going to accept int array on the integer in the demo. So if you click that, for you it will be going to create a private method, static integer called linear search, accepting an array and accepting an integer, and inside that it is throwing an exception. So for now I will be going to remove this one. So like that you can use the thanks to VS Code, with the help of VS Code you can simply quick fix that, and you can it will be going to directly give you these methods. So inside this method what I will be going to do is, so basically I want this 6. So as this is the linear search, I will be going to have simple for loop. So inside this for loop I will be going to start with integer I is equals to 0, and up to where this I will be going is I less than nums dot length. Here you can see we are accepting here the nums, so it will be going to up to the last element, and finally we are going to increment that. So we successfully we are able to traverse this nums. So after inside this traversal, what you will be going to say is if nums of I is equals to target, because we are accepting the target here as well. So we are checking here So this will return the index number I. So we are starting from 0. If the nums of I, the first element is equals to the target element, return the first element's index I. So that's what it is saying here. At last we need to return something also, because the whole return type is integer. So if you not found anything, just simply say return -1. So that's what we are doing. So it will be going to erase the error. So now what I will be going to say, I will just simply compile and run. So it is returning as element found in the index 3. So you can simply customize the element found in the index. That's it. If you are able to customize, you can customize. Okay, now let me recompile and run. You can see it is clearly saying element found in the index 3. You can also clearly see over there. You can see we are passing 6. We are checking for the target element 6. Is this present or not? So if you want to check for the 2 index 2, it is in the last element. So if you again compile and run, it is saying in the index 5. So you can also say 0, 1, 2, 3, 4, 5. So it is present. Suppose what if I have an element like 10, which is not exist in this nums array. So if you compile and run, so it is saying element not found. So that's a simple thing that is the. So if I again come to this slide, and if you see this is the thing that we are going to searching in the array with the help of the linear search. Now if you compare the time complexity and the space complexity in this linear search, so let's understand the time complexity, because for that only we are going to optimize for the binary search if the data set is large, or if the data search is first itself is sorted. So if you observe the time complexity, always you are going to see with the worst case. So if you see the worst case, that is order of n. If element is not present or at the last index. If you're checking the element with the element as 4, so that is order of n. So I hope you understood the linear search. Now if you see the searching algorithms, that is the binary search, we have only 2 searching algorithms. So linear we completed, now the binary search. So basically the binary search is another implementation. How you implement, let's see that. So efficiently find an element in a sorted array by repeatedly dividing the searching interval in half. So what is meant by this is, if you have an array called nums, as you know, the array is the zero-based indexing. In the same fashion, if you also want to find the target, so how you will do that? So first of all, you need to sort the array, because you can see over here it is said that already said mention. So on the sorted array, so it is not sorted. It is the 5, 9, 6, 1, 6, 2, 4. So it should be sorted first. So for the sorting only we have many algorithms. In this session only we are going to see that. So after sorting, the array looks something like this. So 1, 2, 4, 5, 6, 9. So for the sorting, I have said before only, we have these many algorithms we will be going to see in this session. That is bubble sort, selection, insertion, merge, squeak. These are all things we will be going to see. So after you successfully sorting that, what we are going to do is, we are going to initialize this first element and the last element like your wish. So I am going to say the first element as L, that is left, and the last element as R, that is right. Take 2 pointers left and right. So point to the first element of left. So right points to the rightmost element, that is the 5 in this case. So now you need to calculate the mid. So how you will be going to calculate mid? Left plus right by 2. So in this case we have left is 0 and right is 5. So simply 0 plus 5 by 2, that is the 5 by 2. So as 5 by 2 is 2.5, as this is the programming language, 2.5 will be cutted, and as integer it will take 2. So here the second index, that is the mid value. Now we are going to compare this mid value. Is this equal to target? Is this target 6 is equals to 4? No, that's not the correct one. So the next step that we are going to see, we are going to compare. Is mid is equals to target? Is 4 is equals to 6? No. This 4 is not equal to 6. The next step is, we are going to check the target element is less than nums of mid. So what is the nums of mid? So this is nums, this is mid. So nums of mid is 4, the target is 6. So as this is sorted, the 6 will be greater than this 4. So you are going to discard whole this one. Below the 4 you are going to discard. You are going to only consider this one. For more understanding purpose, I am taking the target as 2 and the target as 6 as well. If you take target as 2, so again you need to move your left, or if the target is less than that, you are going to assign the right to mid minus 1. So if the target is 2, as we see now, the target is 2, you are going to take this right pointer, you are going to place on the 1, on the index 1. So that's the simple stuff, okay, in this fashion. In this fashion, you are going to place the right, you are going to move the right pointer to here, and you are going to discard all the stuff in the right side. If the target element is 6, you are going to discard whole this part, and you are going to place this left pointer, and you are going to place the left pointer here. I hope this makes some sense. So move the right pointer here. So what is the use of this? Now only I will explain what is the use of this. Again, recalculate the mid value. So 0 plus 1 by 2, that is 0. So the mid will be placed now here. I will show that. So here also calculate the mid. 3 plus 5 by 2, that is 3 plus 5 by 2, that is 4. So place the mid value there. So as the 3 plus 5 by 2 is the mid value, the 4, that is index 4. Now target element is equals to the 6, that is the correct value. Now here if you compare, so 0 that we are getting mid value of 0, so move the mid value here 0. Now you can see the target value is 2, but the mid array nums of mid is not equals to the target value. Now what we are going to say is, so again we are going to have, we need to compare this mid value. Again we need to recalculate the mid value. Okay, that is again we are getting 0. So after that what we are going to say, with the help of this left pointer, again we are going to move mid plus 1, because the nums of mid is is less than that. So you are going to move this left pointer here. So after that the left pointer, the right pointer, all points here, and the mid also will point here. So then we can say the number is present in this. So in this nums also, if you see that nums of mid is equals to target, so we can simply return true or index number. We can simply return this exist, or we can simply say the return this index number. So that is only that is the thing. You need to merge this left pointer and right pointer in this case, and you can see this matches. If left is equals to right is equals to mid, the number matches. Or in this case, the middle array of nums of mid, if that is equals to target, nums of mid is equals to target, you can say the number exists. So these are the two possible cases that how you can say the number exists. So what if the number does not exist? So take the target number as 3. So before the case as the same. So up to here is the same. The mid element is 2. Up to here is same. So after that what we are going to say is, again we need to recompile the mid. So the mid is 0 here. You can see the mid is 0. Up to here is the same. Now what you are going to do is, you are going to move this left pointer here. Okay, you are going to move the left pointer here, and the mid will be same here. Why the mid will be here? Because 1 plus 1 by 2. That's only. Left plus right by 2. That is 1 plus 1 by 2. That is again the same thing. That is 1 only. So with this also we are going to assume that nums of mid is not equal to target. So with this we can say, or we can return -1. The number does not exist. So this is the code that we have seen for the linear search. Okay. So I will be going to keep this as the same. The array will be same, and the target is also same. But this thing, I will not more than I will be going to say this as linear search. I will say binary. So this is the binary search which accepts the array, and which accepts the target. So in the same stuff that again printing. So I will be going to remove this here, and if you hover over that, it will be going to ask say you quick fix. So it will be going to say create a method binary search in the demo, or you can simply right click that. You can say see source action, click on that. No, in this source action it is not showing. So you can simply hover over that. You can simply click quick fix, create a method. So basically it will be going to create a method for you. Okay. For now I will be going to remove this throw error. Okay. In this method, what I will be going to do is, so as we are accepting the array, as we are accepting the target, with this we also, now we need to calculate some stuff. That is you need to calculate the left value. Okay, that is 0, and you need to calculate the right value. So you can, for the right value, you can simply say the nums dot length, because you know already that nums dot length is the last final most element. So the nums dot length will give you the last element, but it will not going to give the correct index. So for correct index you need to say -1, because array is 0 based indexing, so you are going to say -1. Okay, so in this fashion you are going to calculate the nums of left and nums of right. Okay, so after this what you are going to do is, you are going to mention the while loop. So inside the while loop, if the left is less than equal to right, that's only right. If less than equal the left is less than equal to right only, then we are going to execute the first case. If you see here as well, here not wait. So if you see here also, when we are starting, the left is the leftmost one, the smallest integer, that is 0, and the right is the greatest one, that is 5. So from this we can say, if the left is less than right only, then only we are going to execute this. So if you come here in this while loop, what we are going to execute is, we are going to calculate the mid value, that is left left. So what I will be going to say is left plus right, and I am going to wrap inside these braces, and I will be going to say by 2. Basically this will be going to calculate mid for me. So if I code the mid, so again in that nums of, I will be going to say nums of mid is equals to target. Basically you can see over here we are importing the target, means we are accepting the value target as well. So as we are accepting the nums, with the help of nums we are finding the leftmost the index and rightmost index. In this value what we are calculating the mid, and after calculating the mid you are going to check whether nums of mid is equals to target in the first step. So this nums of mid is equals to the target, whether it is equal to 6, the target is equal to the 4. No. If this is the case, then we are going to simply return here only. So we can simply say return the mid value. Mid means here the index value. You can simply return that, or you can simply else if that. So for example, after below this one I will mention that else if. So basically in this else if what you are going to say is if the nums of mid is basically why I am doing this is else if means you are going to check whether the nums of mid is less than the target. If that's the case, move the right pointer towards the mid -1, do the mid -1. So you are going to have this stuff. So you are going to say else, finally what you are going to say, you are going to return. So this is the simple stuff that what I am doing here. You are not going to do this stuff, but so I hope you may this one all makes some sense now. So if the nums of mid is equals to target, return that mid directly. If else if do the left plus, else if do the mid -1. This and all stuff is clear for you now. So as if, finally as you are returning the integer, so you can return the final integer as well. That is if you not found anything, you can simply return -1 over here. So basically it is all the code is now right, you can see. So we have just did nothing. With the help of this binary search function, we are accepting the numbers, we are the array numbers. So we are accepting the target, and we are finally calculating the left, right, and we are calculating the mid, and we are able to check with the help of this simple if else statement. And if that's not the case, we are simply returning the -1. So that's it. We are just, if you run that, compile and run. Wait, I will zoom out a little bit. So I will clear the terminal for you, and if I compile and run, it is saying element not found. Why it is not saying that? Because you have an element 10. So if you change this element 10 to suppose 5, or if you say that 6. So I missed a small important thing that I forgot to mention, that in the upcoming session only we are going to cover the sorting part. So as why this is giving element not found, because we are not sorting the array. Understood? I already mentioned many times that array need to be sorted for this stuff. So what I will be going to say is, suppose for example I am saying, so this stuff, okay. So I will be going to remove this, and I will be going to play some. So I hope you understood. The array should be sorted. If I search for the 6, so if I again mention the 6 so that you can understand, so I will mention the 6 as well. Now what I will do, recompile and run. It is saying the element is found at the index 5. So the overall code is correct, but due to this small logical error, first of all we are rejecting element not found. But after that we have changed that to the array sorted order. We are going to see all the sorting methods in this video only. So if you check for the 9, it will be going to say, if you recompile it, it will be going to return you index. Or if you going to say the 49, and it will be going to return the index. So it is saying index 9, and if you say somewhat 50, or if you say 60, it will be going to return you the -1, or it will be saying element not found. You can see the element not found. So this is a simple thing that is known as binary search with that we have seen with this. Now we will understand what is meant by sorting. So in the sorting we have many algorithms. We can see bubble, selection, insertion, merge, quick. So we will see one by one. But in inbuilt also we have some methods. So let's not touch that methods, and let's start with the bubble sort method. Before understanding bubble sort method, let's understand what is meant by sorting. Assume that you are given this kind of an array of nums. You already know that is zero-based indexing. So the numbers are having the random order. So suppose you set to have the ascending order or the descending order. You can achieve this with the help of these kind of algorithms. That is bubble, selection, insertion, merge, quick. Any of these will give you the same result, that is this array only. Why these many sorting algorithms you have? So see, for a single solution we have multiple solutions. That is the possibility. So you need to understand that only. For a single possibility, the question is to sort this array. So there are multiple possibilities. So in that, these are some of the possibilities. Other than this, we have many other possibilities as well. But I am saying just in this video we are going to explore these things. So now let us understand what is meant by bubble sort. So the ultimate aim is to sort this one, to arrange the numbers in the ascending order. So I will explain you one by one very clearly. So this is the given array. So if you see in the given array clearly, we have 5, 9. So the first two elements will be compared, the greatest element will be swapped. So compare, swap. So this is the keyword, keep in mind for the bubble sort. Compare and swap. So for the first pass, so mind you, this is known as first pass. So for the first pass, this will be compare and swap. As these are already in the correct order, this will not be affected. After that, then 9 and 1 will be compared and swap, because 1 is smaller and 9 is greater. So as you can see here. So the next thing is 9 and 6 is compared. As 9 is the largest number, it will be coming here. You can see here. After that, it will be going to compare the 9 and 2. You can see the 9 is the largest, so 9 will come here. So finally, now 9 and 4 will be compared, so 9 will come here and 4 will come here. So after completing the first pass, the largest element will come to the last of the array. So this is the first pass. If you see the second pass, as we have stopped here in the situation, the largest element is at the last of the array. So after that, what we are going to do is, again we need to start comparing first two elements. So as you can see over here, we are stopped here. So 5 and 1, we need to compare both of them and we need to swap, because the 5 is greater than 1, so swap both of them. So that is swapped. Okay, next 5 and 6 will be compared, so no problem. So the next that 6 and 2 will be compared, so swap, because 6 is larger. So then 6 and 4 will be compared, then swap. So as 6 is the second largest one, it will be going to take the position of the array last but one position. So by the last of the second pass, you will be going to have second largest number in the second last position of the array, that is 6 in this case. So the next thing is, see, after this also you have some cases, but I am not going to give you that, because I am going to only show the approximate correct solution. So even this after this also we are going to have some other options, but we are going to have in the code. I will explain why we are having these 3 stages. Okay, actually we should have 5 stages. I have removed other 2. Why I will say, because of unnecessary comparisons. Because if you see, this 6 and 9 is already sorted. If you see here, after this first pass, this 9 is already sorted, so don't touch that. So because of that, I removed another case here. So after this completion of second pass, you can see this 6 and 9 is sorted, so completed. So after this third pass, if you see, the 5, 6, 9 is sorted, so don't touch that. So again compare 1, 5, so swap. So there is no need of swapping, so compare 5 to swap that, swapping needed. So after that swap 4, 5, so swapping needed here. So after you can see, after completion of third pass, the third largest element is 5, that is coming into the third position of this, means from the last third position it is coming here. So you can see array is sorted now. So after this, whatever the steps we are having, that is unnecessary, but the computer will check. Computer does not know is the array sorted or not. We need to stop that kind of things. So with the help of code, I will show how to stop that kind of comparisons. So again, it will be going to compare in the 0 and 1 position. It will be going to compare 1, 2 position. Already those are sorted, but it will compare all the stuff. We can stop that the comparisons. So actually we don't want this fourth pass as well. How that we can stop in the code that we are going to see. So as you can see here, as we have seen in the previous session, that is about the searching. So I will be going to clear the terminal. So I am creating an number. So I will remove this the numbers as well. Okay. After having this array, what you can going to do is you can simply say system.println. In this system.println, what you can say is before. So what you can do is you can just print like this statement, and you can have a simple for each loop. So in this you can say int nums, or int array, you can say int array. So you can take the array and you can pass the array nums. So inside this, what you are going to do is you are going to say the array of nums. That's it. What this one going to do is it will be going to traverse print the stuff in the terminal, so that we can understand the stuff what is happening. So I am going to concatenate with this thing with gap. So with the gap you can see very clearly. So this is for before sorting, and I will copy this. So that's it. So this is for the before sorting nums, and this is for the after sorting nums. If you just try to print now what I am doing is I am just printing before the sorting nums, and I am just printing after the sorting nums. So you can see we do not have any stuff over here inside. So you can also append with the gap. So you can see there is no the sorting is not happening, because just we did not have the proper logic here. So for the logic, what I will be going to say is I will create a for loop. So inside the for loop I will be going to have a variable I. So that will be 0, starting with 0, and I will be going to say so less than size. So what is the size? Wait, I will create the size also for the simplicity, so that you can understand. So basically here only I will say int size, because always why we need to calculate the nums dot size. So here only we can say simply nums dot length. So simply calculate force itself, and you can simply reuse the size inside here. So inside this for loop, what I am going to do is again with the help of the nested loop, I am going to have some stuff. So I will explain. Wait. So you are going to initialize j with 0, and again you are going to say j less than size minus 1. Okay. After that you are going to say j plus plus. So up to here, is there an issue? I hope there is no issue here, because this is known as the nested loop. Okay. Inside this nested loop, what you are going to say is you are just going to compare all the stuff, and just that's it. So you are going to say nums of, so you are going to say nums of j, you are going to compare with nums of j plus 1. So if you see the first pass, in the first pass what we are doing, we are compare first as we should understand that. So 0 1 2, this is known as row and this is known as column. So each column you need to compare. So that's the reason inside the second nested loop we are comparing each column. So inside second loop we are comparing 5 and 9. So we are comparing j with j plus 1 and we need to increment j. So compare j plus 1, increment j. So j plus 1, increment j. So this is the fashion that we need to follow here. So I hope this makes some sense. So don't forget that we are comparing j. So after comparing the j, just what you can say here is you can simply inside this, after comparison you can have the swapping. Because if that j is the greater thing, the j is greater than just swap, you need to have swap. So what I will be going to say is in temp, so temp is equals to nums of j, and I will come down and I will say nums of j is equals to temp, or you can say is equals to nums of j plus 1. It's just simple normal swapping only. I am not doing any much more larger things. So you can simply say j plus 1 is equals to, just I am having a new variable called temp. Inside this new variable I am storing the nums of j here. Okay, I am just swapping here. So in the nums of j I am storing nums of j plus 1. Again in the nums of j plus 1 I am storing back this nums of j. So basically this is the swapping, just the swapping thing. Okay, I hope you know this swapping. So that's it, this is done. Now let us see what happens. So if you compile and run, you can see the arrays has been sorted. So 1 2 4 5 6 9. So this is the simple sorting that I can say. So first I swapped all the values and I am printing after the sorting array. Here I am printing before sorting array. In the slides also I said before only. So if I again recompile and run, you can see clearly it is printing the sorted array. There is no issue in that. But if you know inside this stuff, inside unnecessary comparisons is also happening. To stop that unnecessary comparison, just mention minus sign. Okay, now if you compile and run, let's see what happens. So after you mention minus I also, you can see the output is again showing the same result, that is sorted array. So there is no difference between this and this. Then what is the use of this placing minus I in the second loop? Means that is the nested loop. So there is a reason that I have placed minus I, that is to stop unnecessary comparisons. So I hope you understood how to stop unnecessary comparison in the bubble sort. So this is how you represent the power in the programming languages. Basically this is known as the order of big O of power of n, big O of n square. Basically this is. So basically bubble sort is not that much recommended because you have two for loops here. So with the help of only for loop you can do in the other kind of sorting algorithms. So if this bubble sort is order of n square, if we have only 6 elements. Assume that you have 100 elements, 1000 elements. The complexity means n square here, 6 square 36. So that's no problem. So how this n square comes? Because the one loop gives you order of n. Inside also you have another for loop. So that's the reason you have n square. So suppose you have 100 elements. So 100 square, this is a large complex. So you should not handle this bubble sort with the largest elements. So another technique we have here, that is the selection sort. So before understanding the selection sort, we need to see some in the bubble sort only. So in the worst case, we need to consider that is order of n square if whole array is was reversed. If you consider the auxiliary space, that is for the space complexity, it is order of 1. Because we are not we are not taking any extra space to consumed. Okay, in the original array only we are making changes in the bubble sort. Okay, now if you see what is meant by this selection sort. So selection sort is also order of n square, but it is very important to understand the difference between bubble sort and the selection sort. So there are some sorting techniques that might take order of n log n, which is compared less than the order of n square. But this selection sort also we need to understand. This is also a nested loop concept. But you see this is the original array. Suppose you have elements like 22, 13, 64, 12, 33. You want to make this array sorted to this format. So how you can do that? So in this whole array, you can check where is the smallest element. So the smallest element is 12. So you can take the smallest element of this array, swap with the first element. Understood? Swap with the first element. So after swapping, you can get 12 to the first element. So after 12, what is the smallest element of this whole array? That is 13. That is in the right position. So don't do that. So don't change that anyone. So these two elements are sorted. Now in this unsorted array, what is the smallest element? That is 22. So place this 22 to the next of 13. So I hope this makes some sense. So after changing this 22, you after swapping these two elements, so up to here, this is the sorted array. So in this 64, 33, what is the smallest element? That is 33. So swap this 33 with that after 22. So this whole will give you the sorted array. So I hope this makes some selection sort. Now what is the importance of this selection sort? As this is also order of n square. So this is very important to understand the selection sort because it is very simple. How you are selecting and how you are keeping the elements in spite of like bubble sort. It is coming like a bubble from the bottom of the lake to the top of that. So quickly I am going to clear the terminal and I am going to take this out the bubble sort code. So okay, all the remaining code, all the remaining stuff is same here. So if I remove this here also, say there is no error because if we are printing before the sorting array, here we are printing after sorting array. If I compile and run C, so it will printing before sorting array, after sorting array. Basically it is not sorted. So both the arrays are same. Now what I am going to do is I am going to introduce some logic in between here. So that logic is I will say selection sort. Okay, in this selection sort what I will be going to do is, so I am going to have something known as here the min index in. So basically how we have seen in that slides how we are going to take the minimum index, all the stuff like that. So I am taking the minimum index as the -1. It's not I, so take the minimum index as -1. Okay. So in the selection sort what I will be going to do is, so basically I will be going to have a for loop. Inside this for loop I will be going to have an I is equals to 0 and I will be going to go up to the size. Okay, basic I have calculated directly over here the size. Okay. So after calculating the size, what is the operation that you want to perform? I want to perform I plus plus. So if you want to descending order, you can start with the I is equals to the size. So you can go up to the 0 and you can do I minus minus, that is your wish if you want descending order. But in this case, I am going ascending order, so that's why I am having in this fashion. So to reduce the unnecessary comparisons or the last element, to get the last element, you can mention size -1. Post loop only, I am going to set this min index to the I. So in this first loop only I am going to set the minimum index to the I. So there is no issue in this, I hope. So next inside this I am going to have another for loop. So I will be going to set j. So j is initialized with I plus 1. Okay, there is no issue because if you initialize I with 0, you have to initialize with j is equals to 1 because you need to compare. Okay, after that you need to mention j less than the size. Okay, there is no issue in that. And the operation that I want to perform is j plus plus. So up to here I hope there is no issue. So inside this for the nested loop you are going to perform the comparison. You are going to say the minimum index, so that you need to compare with the nums of I. So that is as simple as this. So you need to just compare with the help of this if statement. So inside this if statement what I will be going to say is minimum index that I will be going to set with z. So I will explain now. So first of all you are going to initialize this minimum index with the first index, that is index of 0. I hope this is the minimum index with 0. So if you want you can also have the minimum index 0 as well here. So there is nothing like this. Okay. So as you are going to initialize with minimum index with I, so every time you are going to initialize with minimum index I. So inside this nested for loop what I am going to do is I am going to compare the nums of index I. So if you see clearly over here, so the first the nums of minimum index, nums of 0 is 5 and the nums of I here is nums of I here is the 5. Nums of minimum index is also 5. So both are same. So it will not be going to enter here. So after this what I will be going to do is just I will swap the elements. So after the for loop you can see clearly I will not do here after the for loop. So after the for loop I will be going to say, after this for loop what I will be going to say is int temp is equals to nums of minimum index. Okay. So just for the swapping purpose I am just doing, we already seen how to swap that stuff. So again I will be going to start with the minimum index. So after that I will be going to say nums of I. Okay, just put colon here, and after that you are going again going to say nums of I is equals to 10. That's as simple as that. Already we have seen how to do swapping the stuff. So finally we are printing the stuff in the terminal. Okay, see clearly what I have did is just nothing. So I am basically I am in the first for loop. With the help of this first for loop, I am going to assign the minimum index to the I. Okay, we have already declared here I is 0. So I am going to initialize this minimum index with 0. So inside this nested for loop, what I did, just I am comparing the j with the minimum index of num of j's. So if you see this array nums of minimum index, so minimum index is 0 here. So nums of 0 is what? Nums of 0 in this case, our case is 5. Okay, we are comparing that 5 with nums of j. What is I plus 1? That is the 9. So we are comparing 5 and 9. So yeah, of course, the nums of minimum index is what? The first element. So the first element is the greater? No, it is not greater. So as this is not greater, we are going to simply just traverse all the stuff, and we are going to, if the reverse is case, we are going to assign minimum index as j. Okay, after traversing all the stuff, that I am going to have this swapping thing. So I hope this makes some sense, because why we are not doing swapping here, because this is already swapped. If you compare these two stuff, then it will be going to, first it will be not going to execute this one for the first two elements. So after the stuff, after it executing, we are going to swap these two stuff. Okay, it will be going to traverse all this array. It will be going to traverse all the array, and we are going to get some minimum index. So with this minimum index, we are going to have the swapping, this kind of stuff. Okay, I hope this makes some sense. So after swapping the minimum index like this, and again we are going to call this. So that you can see here. So according to, so first of all, we are assigning minimum index in the first loop, according to the row wise. In the row wise only we are swapping. So inside this next loop we are going to swap. So basically what I am trying to say is, with the help of this outer loop, so you are going to check all this stuff, and with the help of this loop we are going to traverse all the stuff, and we are going to get minimum index. So with the help of the minimum index, you are going to swap the stuff, and here in the outer loop only we are going to swap the stuff, and finally after completing all the array completion, you are going to have the printing in the terminal. If you compile and run, see, that's the stuff. The array is sorted order. This is the selection sort. I hope you understood. Select an index, place to the first. Select an index, place in the second. Select an index, place in the third, like that. The selection of the index that you are selecting is the smallest element. You can also select the largest element and keep the last, and you can also select the largest but one element and keep in the last, and like this the backward stuff also you can do. So if you see, for the selection sort, we have the order of n square, worst complexity. So as bubble sort, the selection sort also have n square 1. We are not going to have any other stuff in this. So in this session, we are going to understand what is meant by insertion sort. We have seen two kinds of sorting techniques, that is bubble sort, and second one is the selection sort. Now in this session, we are going to understand the insertion sort. So insertion sort is nothing but, whenever you play cards, normal cards, that 52 deck of cards, that when you are playing, how you will play that. So whatever the correct card that you will take, and you will place in the correct position. So that is the simple way of saying you what is meant by insertion sort. So if you read the sentence that is present over here, it is saying taking element from the unsorted section, place in the sorted section. So that is the meant by a simple definition of the insertion sort. So let's say, assume you have an array called nums. So 0 index base, so you have 5 elements. Okay. So now as you are taking, as this is also order of n square, because you are going to have nested loop. So with the first loop as I, the outer loop, and the inner loop as j. But here you need to understand that j is the before of I. Means if I is the first index and j is 0 index, so that means j is equal to I minus 1. That's the simple thing that you have understood. You can also see the same stuff here also. So basically you have the array, you have the I is equals to, suppose I is equals to 1, and the j is equals to I minus 1, which is 0 in this case. You can see clearly over here. And we are going to have another variable called key, which is indexed with nums of I, which is in this case as the 6 value. Okay. You can also see that nums of I, or we can also call it as key. We are assigning this key value to the 6. So why we are assigning key? So I will explain to you in a moment. So these are from the, if you see, this is the small, this is for outer first loop. So we are initializing I with 1, you can see over here, and I less than n, I plus plus. So we are taking a variable key, which is for the nums of I, and integer j, which is I minus 1, means j is pointing here. So after that, the nested loop, the inner loop, that we are taking nums of I, so nums of j, which is greater than key. Now what we are going to compare is, we are going to compare j and key. So you will understand that what we are going to comparing. So first of all, we are going to compare the j and this. Now here what I did is, basically if you see clearly over here, I am comparing 3 and 6. So there is no issue. I got forwarded. If you see clearly here, I am comparing 6 and 2. So if you compare 6 and 2, which is bigger? Of course 6 is bigger. So take this 6 to here. a simple problem. But don't keep these two directly over here. That if you do that, then the bubble sort will come here. So don't do. Instead of that, take these two out and keep in this key. So as you can see now, why I am keeping key as 2, because the key is now nums of I. After that, move the nums of I here, as the nums of I is this one. So that now key becomes 2 because you take out that key. So now compare this key and this j. So move this j here also. Okay. Now j is here and place this key here. Okay. So you have placed j key here and you have placed that 3 here. Now you can compare. After that, you are mentioning the j minus minus. So after that, j minus minus means there is no space, it is going to -1. So that is not possible. So if you observe, what I am saying is, so nums of j plus 1 is equals to nums of j. So what is meant by this statement? So as in the before here only, you can see nums of j plus 1 is equals to nums of j. So so whenever j is not here, you can put j here. So nums of j here means nums of j plus 1 means here. You are assigning the value of nums of j. So what is the nums of j? Nums of j is 3. So basically this 3 will come here and nums of j will be here. Nums of j, okay. Now what is meant by this statement? After that, you are going to do j minus minus. So j minus 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 is nothing here. So now here comes is j into j is equals to I minus 1. So if whenever you see this statement, so in this while only you have to mention another condition. The condition is whenever you that condition works, the while loop works only when this j greater than equal to 0. Okay. So j will be not going here, then you can simply assign this keyword. So nums of j plus 1 is equals to k. So as you are storing this key here, so as you are storing key here, so simply place this key inside this j plus 1. Okay. As you are moving j here, so place simply j here. So after that, what you can do, so as the I is as I is what? I is 3. You again moved I here. So as I becomes 3 here in this outer loop, I am saying I moves here, then j also move to I minus 1, which is the second position. So with the help of this loop, again you can check whether the nums of I here, the nums of this condition, whether the nums of j is greater than key. What is the nums of j now? 6. Whether this 6 is greater than key, key is 1 here. So you can see that is not correct. So you are going to swap. Swap means place this 6 here, take this one out, keep in the key. Okay. So after keeping the key inside this one, again you are going to move this j value here. So after moving j value here, you are going to assigning this with the help of like this here. So I hope you can relate this code with this diagram as well. Okay. So after that, what you are going to do, again you are going to place whatever the condition 3 here, you can move here with the help of this line, and you can move the j backward like here. And the the key is again the still 1. Okay. So finally you are going to place the key value here, and you are going to move the I value to 4 and j value to I minus 1, which is 3 in this case. So you are going to finally take out this key here and keep in the key value and swap this key which is j value, which is 6 here, which I have done here. So because with the help of, like, if this condition satisfies these two conditions, with the help of this statement I swapped. Okay. And I moved j backward with this statement. Okay. Now what I am doing is key value, you have to compare this key 5 with this j value. Why? Because here I am comparing array of j with the key and I am placing that value here. So these conditions has been true, so I am coming inside here. So you can see the array of j, this condition false. So this condition has been false. So this condition is true, but this condition has been false because key value is what here? Key value is 5 and array of j value is what? Array of j value is 3. As array of j value is greater than this one, you are going to simply place nums of j plus 1 here. So you are going to place 5 value here. That's it. That is the condition, and you are going to finally place this nums of j plus 1, which is this here. That's it. So in the previous session we have seen up to here. Now I am going to change it to the insertion sort. So this will be insertion sort. Okay. In the insertion sort, we have understood in the theoretical way. Now we are going to see practical way. So now I don't require this minimum index because we are not dealing with anything in the minimum index. So I will be going to remove this minimum index. So I will be completely removing of this inner loop as well. Okay, this is a simple outer loop. Okay, there is nothing complex here. Now what I will be going to say is, I will be not going to place rather 0 here. I am going to start the outer loop with the 1. Now I will be coming here inside that I will be going to make the inner loop, which I will say array of what? I will be going to compare with array of j, and here I will compare with key. So I will make the key as well, and I will be going to place AND operator here, and I will also make sure make sure that j is greater than equal to 0. So there is no issue, but before this while only you need to make a the variable called key, which will be initialized with this the nums of I. So there is no issue in this, and you also need to initialize the variable j. So I will say int j is equals to I minus 1. So generally the basic stuff that we have seen in the slides only. So I will clear this terminal first for you. Okay, so initialized the not array here, we are doing with nums. Okay, the array name is nums, you can see clearly over here. The array name is nums, and you also initialize the size. Basically you are using the same size here also. Now inside this basically inside this while loop, what I am going to do is I am going to do 2 steps. So as you see in the slides as well, so I am going to have the array of j plus 1 that will be replaced with array of j. Okay, that's a simple step, and I will also going to perform j minus minus. So this is the simple, oh, not the array, that's num. Sorry for my confusion, this is not array. We have the array called nums, not air. Okay, not air. So you have made array of j plus nums of j plus 1, which is replaced by nums of j. So after that you are subtracting that see in the slides, this one nums of j minus minus. Okay, as this is moving back. So with that this condition it will be going to C front only. So basically what is meant by that is you are seeing, make sure that this j, this not only you just swapped means what is the problem, that becomes bubble sort, right? So you don't want that. So this key value should be compared with all these values and placed at the right position. So that is known as insertion sort. Insertion sort means you are taking the key value and placing wherever it fits. That is as you place in the actual deck of cards when you are playing, how you will from all unsorted arrays, unsorted cards you are placing in the sorted position. So similarly you are taking this unsorted key value and placing exactly where the value suits. So again if you come to the code part, so after this while loop what you are going to say is again the final thing, that is in this nums array of the nums plus 1 you are going to store the key value. So like this you are going to end all this stuff, and if you, so before that I am simply printing the stuff in this nums. Okay, after that after the sorting also I am printing the stuff. So if basically if you compile and run, so you can see, so if you compile and run, basically it is showing before sorting the nums, it is showing this one, and after sorting the array it is showing like this. So this is known as insertion sort. So basically in the insertion sort you are also going to have 2 loops. If you are using 2 loops, definitely mark by word, that is order of n square. If you are using 1 loop, that is order of n. As you are using 4 loop, inside that you are using again while loop, that is order of n square. So all the 3, the bubble sort, the insertion sort, the selection sort, all of these 3 are the order of n square because you are using 2 loops here. So in the upcoming sessions also we are going to explore more sorting techniques. In that is more sort and all things we are going to have in the order of n log n also. So that makes our that is very faster as compared to this insertion sort. So in the outer loop you are having a key value and the j value which is less than I, mind that. And in the while loop you are just replacing the values or swapping the values. Now outer loop you are keeping the actual value in the actual position. Here you are printing, here also you are printing after the sorting. So actually the last thing that here is we have left is the time complexity and space complexity of this insertion sort. So you need to consider only the worst case scenarios. The worst case scenario of this insertion sort, the time complexity is order of n square as you are using 2 loops. So in the space complexity is order of 1 because we are not using extra space for the arrays. In the same array we are doing all the stuff. Hi guys, in this session we are going to discuss about the merge sort. So merge sort is also a very important concept. So before seeing that, so let me explain these slides so that you can understand first. So in the previous sessions we have understood what is bubble sort, what is selection sort, what is insertion sort. So in this video we are going to see what is merge sort. So merge sort is a divide and merge type of divide or conquer, divide and merge anything algorithm. Recursively divides the list into half, sorts the half and merge them. So how that happens, let us see first. So assume that we have a array called nums and the first element, let's say L, that means left, and the last most element, let us say R, that is right. So if you want to get the middle element, how you will do in the binary search the same way, how the left plus right by 2, which gives you 2. So actually that is 2.5, the 0.5 will be cut out because that's integer. So basically whatever the value that is in the position 2, that is your mid position. Now you have to start dividing. Okay, first of all how you will divide. So up to this position 1/2, up to this position 1/2, let's see. So this is the way how you divide. Up to this position 1/2 I said, up to 1 this position 1/2. How you divide it? Because based on the mid position, as mid is position in the second position, up to that we have to divide 1. Up to after mid we have to divide it 1. So I hope you know. I hope you understood how to divide these two positions. So after this position, after this, how you divide another. You can also divide 8, 5, 9, and separately 9. You can also you can have a question like I can also divide 8 separately, 5, 9 separate like here. You can also have like that question. So for that clarification only I am showing here also for this division how I did. So mid is L plus R by 2. As we have 0, 2, we can simply say 0 plus 2 by 2, that is 1. So up to one position you need to divide one side, and after that one position you need to divide another position. So you can divide 5, 9, one box and array, and 9 as another. Not in the nums array. You are dividing manually. You are dividing all this as logical only. These and all things is a one array only, not separate arrays. Only one array. In the only one array you are dividing logically. So after in the same fashion how you divided here, the same fashion divide here also. So after this you have two elements in a single array. So why divide that as single element. Here also divide single element. So make sure that you have only one element at the last. So 8, 5, 9, 1, 6, 7. So like this in this fashion, make sure that you have only one element in that. So after dividing, the next step is, so you should see here. So this is known as division, divided. So you are dividing this larger array into small pieces. So the next thing that you are going to do is known as merge. So how you will perform merge? So basically up to here we have leftover. So we have separate each and every element virtually. So now how you can merge is, first of all take two elements, so merge them. So before merging, make sure they are in the ascending order or descending order how you are required. So basically this is the stuff that I am saying about. If you all divided arrays, that how you can merge that. So you have left array and you have right array. So simply merge in this fashion, and you have the left array and right array. Simply merge in this fashion. So finally you are going to get this array of 3 elements here and array of 3 elements here. Here L means the left array. So left array you are having 5, 8, 9. The right array you have 1, 6, 7. So while merging both of them, you are going to get the final array in the sorted order. But make sure when you are merging both of them, you are going to have the ascending order. So how can you achieve when merging? You can get the ascending order. So you have to compare the left array of 0 with the right array of 3, or right array of 0. So in this fashion you will get this order. Okay. So the left array of 0 is 5 and right array of 0 is 1. So basically compare both of them. So 1 is smaller, so place here. Then increment the right array, and after incrementing you are going to compare this 6 and 5. So as 5 is smaller, though you are going to place here the left array of 0, yeah, right. So after that you are going to make sure that the left array will be incremented. So left array of 1 will be 8 and the right array of 2 will be 6. Now what you are going to do is compare both of them, this 8 and 6. So as 6 is smaller, place 6 here. So after that increment the right array of 3, it will be going to right array of 2, sorry. So place this 7 here while comparing with 8. So after that you are going to place 8 here, and finally the remaining element is 9, place here. So basically I have a small code snippet over here. Up to now what we have seen the same stuff, that you have an array called nums and you have measuring the size of the array with the help of the nums.length, and you are printing the stuff here in the terminal. So basically I will clear the terminal, and if I print that, so it will print all the stuff in the terminal before sorting that. So after this after this main method, what I am going to do is I am going to say, so private, so as this is in the same function, so same method, demo, same class. So I am going to say private, and I am going to say static. So void, basically this is the merge sort function that I am making. So say merge sort. What this merge sort will do, so basically this merge sort will accept an array named array. I will name it as array. So I will also int L, okay, int L, that is left, and I will say int R, that is R. Okay, in this function what we are going to do is, so we are going to say if you have the left less than right, then we need to perform something. If left less than this one, if left less than right, if the particular condition is satisfied, we are going to calculate the mid value. So of course I hope you know all of you know how to calculate the mid value, that is left plus right by 2. So after calculating the mid value, you are going to call, actually you can see while dividing. So the first part is to divide the given array. How can you do that? Basically this array will call basically this will call this one, this will call this one, this will call this one, like this. once you want to divide all the stuff, this part will divide it into this part, this part, this part into divide this part, this part, this part, this part, like that. All will be done recursively. So finally this will say I am done. This it will go to this, this will go to this, this will go to this. So the final thing is we can achieve this kind of all small blocks with the help of recursion. So basically this should also be inside this if L less than R. So inside this merge sort, inside this if else statements, if statement, I am going to call recursively this function only once again. So with the help of the mid value, left value and comma, the right value is mid. So inside this merge sort I am going to pass array mid plus 1 and R. So basically why it is showing a warning, because we are not calling that function. Okay, that's why showing error. So we will be going to call that, no worries. So after this both of the merge sort calls, so I am going to call the merge function. So inside this merge function I am going to pass array. So I am going to pass the left value, I am going to pass the mid value, and finally I am going to pass the R value as well. So basically this is the merging part, how you merge. So you currently don't have this function hover over that. You can see quick fix. So click on that. So it will say create method merge. Okay, I will click that. So it is going to create a function for you. So inside this void merge function I am going to accept array, left, mid and right value. Okay, inside this merge function what I will be going to do is I will be going to create two functions here. So the divide part has been successfully completed. So after the divide part you need to conquer, means, or you need to merge that all divided parts one by one. So first of all I have two arrays called left array, right array. So I will come here. So inside this one what I will be going to say is I will be going to say in n1. So this is the mid minus L plus 1. So you are going to have a variable that is n1. So I am going to have another variable that is n2. So basically these two will store the size of each and every value. Okay, R minus mid. What I am trying to say is this will store the size of this one, each, and see this is the size of 2, array of size 2, array of size 1, array of size 2, array of size 1. So the array size is changing dynamically. For this reason only we are just in this fashion. So the n1 and 2 are the sizes of each array. Okay, after that what I am going to do is I will be going to create a new array. So I will create a new array with the size of n1. In the same fashion I will also create R array with the size of n2. So basically what I am trying to do is I am creating two variables and with the name n1 and n2. So this will be this value, which this is n1 and this is the n2, n1, n2. And what I am trying to do is I am creating left array, and after that I am creating right array. So the left array size is the left array, that is you are creating new and int of n1. For the right array you are going to say new keyword int size of n2. I hope you are this makes some sense. So if you see this left array, you are having this, the size is n1, this is the size n2. Also you got n1 size, n2 size, and you naming this array as L array, you naming this array as R array. So in the L array, how you will create this one? So L array is a new int of size n1, R array of new int size n2. So after that you are merging means you are getting this. So I hope this makes now some sense. So as you created successfully, you need to copy the values, okay, one by one. By how you will copy, you will be going to compare both the stuffs and you will be going to copy the values here. So in the ascending order you need to copy. So I will be going to say, suppose I have a variable x, so I am initializing with 0. So after that I am going to say this x would be less than the n1. I am going to increment this x plus plus. So this is the simple stuff that I am did now. So after this, in this for loop, what I will be going to do is I will be saying L array of x. Okay, I'm just copying all the stuff here. So L array of L. Okay, you understood this stuff, I think. Now basically I will be going to copy this, means I will be going to reuse my code. I will say again x is equals to 0, and I will be going to say now x less than n2, and I will be going to say x plus plus. Okay, so finally here I will say with the help of R array. So with the help of R array, I am going to have in the array, this is array. Okay, in this array what I am going to say is I will say, so after this for loop also what you are going to do is you are going to say int I. So after this you will be going to say int j is equals to 0. Okay, no problem. So after that you are going to say int k is equals to L. That's also no problem. Okay, so up to now I am copying all the values in the smaller arrays. So basically you are creating array here, you are also creating another array here. So both with the help left array and right array you created here and copied all the values as it is all values of the array inside this L array. Okay. So after that you need three variables. So L, J, K to copy to the ascending order. So I take that all. So I will be going to have a while loop. So inside this while loop I will be going to check the condition if I is less than the n1, whether the I is less than n1, and I am going to again check the value that j is less than n2. Is that j is less than n2 or not? So these two conditions I will check. After that I will be going to have the if the else case. So I will be going to say L array. So inside this L array I. So I hope this makes some sense now. So you are just comparing with this if statement. So after that you are going to, what you are going to say is, you are going to, if this condition satisfies, if left array is less than or equal to the right array. Actually this condition is true, that's why all the statements inside that has to be executed. So simply say the array, this k means to copy all the values. So this left array, right array, then who will control this new array? This new array should be controlled by something. So that will be controlled with the help of the variable k. This will be controlled with the help of variable I. This will be controlled with the variable j. Okay. So L of I will see this one. So R of j will see this one. Now when you copy these things, so this thing should be controlled with the help of variable k. So this is the simple stuff that I am doing. So I am trying to assign this array of k inside the new array. So I am going to copy all the stuff of the right array. So this makes some sense now. So and after that I am going to say I plus plus. So with this I am going to place semicolon. So with this what you are doing is, you are just copying all the stuff here inside to this one by checking this and this. Okay. So you are going to say this as L. So this small index 5 with the I. So this index is represented with j. So this index represented with I. This index represented with j. So L of I will compared with R of j, and again merge to a new array as k. This will be a new array which is managed by variable k. Okay. So when you are merging these two to this one, this is managed by with the help of variable k, and these two are managed with the help of variable I, this one, variable j for this one. Okay. So I need to have the stuff inside this, otherwise it makes some. So after this if statement I am going to have else statement. Inside this else statement what I am going to say is, I am going to have the array of k. I am going to copy all the stuff from the right array. Okay. Up to now what we have copied is from the left array. Now with the help of these statements we can able to copy all the stuff with the comparison. Again say, with the comparison we can able to place the stuff, and you are going to increment the value. Here you are going to say j plus plus. You are going to increment the j value and place semicolon. Okay. After this if statement and else statement, again you are going to increment the main k plus plus value. So first of all, if you merging these two to these two, so basically you are comparing I and j, L of I, R of j. So L of I is 5, R of j is 9. So L of I is small, place it here. Now L of I is incremented here. Okay. So in the if case only we are here. So L of I is 8, R of j is 9. So as L of I is small, place here, R of j, the final remaining thing, copy all the stuff here and increment the k value. Okay. So when you are moving here also you are going to increment the k value, otherwise how you will traverse here. So after having this one here, after having this one here, then the next the main array, this has to be updated with the variable k. In the while loop you are seeing that only. You are updating the outer loop with the k plus. Up to here there is no issue. No, there is no issue. So after that you also place 7. So after that there is no any comparison required. No comparison required. You can place all the stuff 8, 9 directly here. But there is a catch. You should also have a while loop to place all the stuff directly over here, from this main array. So for that only what I will be going to say is, I am going to have a while loop. So in that while loop I am going to have a j. So j variable I am going to have the length less than n1. So I am going to open like this. Okay. I am going to say array of k, which we are copying all the stuff. So I am going to copy array of left array with elements of I. So there is no issue in this here. So I am going to increment I plus plus. And finally I am also going to increment k plus plus. Why I am incrementing I and j? Because we are copying the left array elements to the main elements. Increment I. Basically what is meant by that is, so copy all the stuff. If any element remaining in this, so copy all the elements to here and increment the left value and increment this k value. Okay, because this is the left array we are copying here and we are incrementing this k value. So this is controlled by k. So as this is controlled by k, we are incrementing k value. As we are copying values from this, so we are incrementing the value of I. So in the same way, we are going to increment you are going to copy all the stuff from here to here if any value remaining here. So and we are going to increment j value and we are going to increment k value. Okay. So I came here and if I just reuse my code, so copy here and just come here, paste here. Now what I will be going to say in this is I am going to say j is less than n2. So here it is ni. Okay, there is no issue in that. So j is less than n2 and the array of k elements you are going to copy from R array. And inside this, what you are going to say, you are going to have j, and you are going to increment the value of j, not k value. Okay, up to here, any doubts? There is no doubts. So this is the complete code for. So you are able to going to have this private method called merge sort. So basically this will accept an array left value and right value. So inside this we are going to have a single if statement. Inside this you are going to see the left is less than right. So if that's the case, we are going to calculate mid value. So first of all, recursively we are dividing the left side. Recursively we are dividing the right side with this part. Okay, you understood the syntax, I think. So after that, I'm calling the merge function. Basically, this merge function will merge all the stuff what you are dividing with the help of this left array and right array. So this also will accept the left side, the array main array and the left side, mid element, right side. So after that, I took the variable n1 and n2, which will store the size of the left side and right side of each element. Okay, and I am creating a new array. Okay, the left array and right array to store the values and with the initialize with the sizes of this n1 and n2. So we should have dynamic sizes because we have dynamic varying array sizes. So that's the reason we need to create a new two arrays. So after creating that, what you want to do is you are going to copy all the stuff with the help of these two for loops. So you are going to require three variables I, j, k. So I is required to manipulate the values for the left array. So j is required to manipulate the values of the right array, and k is required to manipulate the values of the main array. And the length of this is L. Okay, then the length of this is L. So you can see the size also we are passing here, which is at 0. Okay, for this starting position. So after that you started. So this is the main array. In this main array only all the stuff is able to copy from the both the arrays and placing here. So in this main array, what we are doing is we are able to see comparing the left array the I. So basically with this in the while loop, so I am checking the I is less than n1. So as you are taking the input that is n1, the smallest size array here the first time. So that will be compared with I. What is I? I is 0 here. So this condition will be checked and this condition also will be checked because n2 is taken from the smallest array size here. As we have already divided, now that's the time to merge. So for the first condition to merge, we will be going to check these two conditions. So after that, what we are going to compare is if the left array of I is less than or equal to the right array of j. So we are going to place the values, the left array values to the main array, okay, which is controlled by k, and we are incrementing the I++, where that is for the left array. In the similar fashion, else we are going to copy all the values to the with the help of the right value, increment the j value. Okay, that's no problem. Now after completing this if statements, you are going to update the value in for the main array also. Okay. Now what I am going to do is after that you are going to copy all the remaining stuff. If any values remaining in both any of the array, you are going to copy both of them to the main array, that is k. You can see I am incrementing from the I am copying all the stuff from left array, pasting here, and incrementing both I and k. So I am copying all the values from the right array, incrementing the right array variable and the main array variable. Okay, I am creating these two functions, but okay, this merge function is called in merge sort function. There is no issue, but we did not call this merge sort function. So basically what I will do is I will be going to call this merge sort function. So basically you can see clearly over here, just I placed both of the methods, void that void merge sort function up to, and this merge function also to the up. So I can have clear main function here. So before that I am printing some stuff in the up, and I am also printing some stuff in the down. So that is after the sorting numbers. So before in between I am calling this merge sort and passing the nums and the left array size and the right array size. So means the left size and the right size. The left size is 0 and the right size is 0 size. You can see we are accepting three values. The full array, accepting the left value, and we are accepting the right value. So I called here, and it will be going to print after the sorting. So let me run, compile and run. So it is saying some error. So before sorting nums, exception thread, okay, array outbound. So what I will be going to say is I will say array -1. So let me try it now once. So you can see clearly it is working fine. You can just simply come here and you can say inside print, don't do anything, and try to do that. So you can see here, so first of all it is saying before sorting the nums, and after it is saying after sorting some nums. So this is known as the merge sort. So I hope you understood all the stuff. So we are making the merge sort function. In this we are calling the merge function, so it is calling this function. So here we are able to call from this main method. So finally we are printing before that and after the sorting. And if you see this presentation, in this presentation we have understood all this before stuff. Now we are going to understand the time complexity and space complexity for the merge sort. So if you see for the merge sort, the time complexity is order of n log n. This is the as compared to that other three sorting algorithms that we have seen in the previous sessions. So that is the insertion sort, selection sort, and quick sort. So as compared to that, this merge sort has the compared to that is those have big O of n square. Here the merge sort has big O of n log n. So this is as compared that good. So we can reduce the time complexity with the help of this merge sort. So this follows divide and merge concept. So if you see the space complexity, it will be order of n, because we are not we are using some space. We are using the left array, right array. So that's the reason it is showing the order of n complexity space.